Go for it. Hello. Hello, good morning everyone. Nice to see you all here, nice and early. So obviously we're now in the middle of the Cambridge Tech Week portion. It's been quite a busy week, and today's all about the semiconductor discussions. We've got a couple of presentations and 3 panel sessions, and I'll be your MC. So to introduce myself for those who don't know me, so I'm Raj Guerra. I head up a couple of R&D centers for Samsung Semiconductor, and I've been in semi and wireless for about 25 or 30 years. So very interested to hear what the experts are going to say today. Like me, you probably got a lot of questions about the geopolitics, about the technology trends, about the business models, and of course how UK can navigate in this global arms race for semiconductor. Now, a few housekeeping items. First of all, please silence your phones, unless you've got an amusing ringtone, then that's allowed. And also there are no fire alarms, so if you hear something, then please do get up and walk. So we need an exit. And the assembly point is Chew Court. I don't know where that is, but I'm sure someone will navigate us. Now today wouldn't be possible without our sponsors, and there are so many sponsors that we had to put them on 2 slides. So this is the first slide, and actually it's some quite good names there. And the second slide. So thank you to everyone who's sponsored this event. And a special thanks to Cambridge Management Consulting, who are the venue sponsors, and we'll be hearing from Tim shortly to say a few words. And also another sponsor, UK Tin, who've made this event possible. And you probably notice I'm going pretty fast through this. I was given 1 minute, and I'm just about with 3 seconds left. So without further ado, I'll hand over to Tim to say a few words. And I think he only has 1 minute as well. So let's welcome him. Thank you. Well done.
Great, Raj, thank you very much. I was given 5, but I'm going to compress it now to give the other speakers a little bit more time. First of all, a very, very warm welcome to Day 4 of Cambridge Tech Week, and a welcome on behalf of 2 organisations that I represent. First of all, as Chairman of Cambridge Management Consulting, and second, as a William Pitt Fellow of Pembroke College, where I do a little bit of work here at the college to bring the worlds of academia and business together, and I'll come back to that a little bit later. But I hope you've had a fabulous week. If you're here today, obviously, for the Semiconductor Deep Dive, here or at the scale-up sessions in the Union, have a fabulous day. I don't know about you, but I've learned an enormous amount this week. I think Cambridge Tech Week, and huge kudos to Cambridge Wireless and the whole team that have helped bring this week together, but I think it's been absolutely fabulous. I've spoken to people from over 20 countries, from pretty much every industry vertical, whether it's finance, pharmaceuticals. I was on a panel with the head of innovation from Lego, which was brilliant. You know, the diversity and the interest and the great stuff this week is testimony to the Cambridge ecosystem and the power of that ecosystem. But on behalf of the college, a massive welcome to Pembroke. Let me share with you a few things about Pembroke College. If you were here yesterday, you heard from the Master, Lord Smith of Finsbury, Chris Smith. Pembroke College, founded in 1347 by Marie de Saint Pol, the Countess of Pembroke, originally Pembroke Hall. It's the 3rd oldest college in Cambridge, but many people don't appreciate it's the oldest to have always been on the same site in Cambridge. So opposite here, that original site is where the college has always been since 1347. This is the new part of the college. We're in a previously United Reformed Church that the college has now taken back as part of the development of the new site that we call the Mill Lane site, where we've got a new partnership centre, new accommodation, and this fabulous new facility now that's available for Cambridge Tech Week and others to use and for academic purposes. It's appropriate we're in a chapel, because one of the things that Pembroke is most famous for, a type of innovation, if you like, from back in the day, was it was the first ever college to have any form of chapel within its grounds. We hosted a fabulous innovation session earlier in the week in the old chapel, which is now referred to as the old library. And the new chapel, in inverted commas, was the first ever public work by a rather talented young man called Christopher Wren, who went on to build bigger and better things, such as the William Pitt building next door, Trinity Library, and obviously, eventually, and most famously, St Paul's Cathedral in London. But the first thing he ever did, thanks to his uncle, who was previously Bishop of Ely, Matthew Wren, and then Master of the College, was to design and build the Wren Chapel opposite here, which is a fabulous location. And if you do have time, please do. The college is open. Please do take the time to see the old college, see the Wren Chapel, the new library, in inverted commas, which is one of my favourite buildings in Cambridge, and make the most of being here in Pembroke. One of the other things that makes Pembroke unique is the engagement with industry and the wider Cambridge ecosystem. Pembroke has the most tremendous corporate partnership, and if you're enterprise, if you're fund, if you're from finance, if you're startup or scale up, wants to get better access, better understanding, better engagement with the university, then the Pembroke Corporate Partnership and the partnership team are fantastic, and I would really encourage you to speak to some of them that are around today. Contact me offline if you're interested in learning a bit more about that, because it's a great way of engaging with the university in a really good way and helping. And if you've already made it and you no longer need to work, but you want to give something back, it's also a great way to engage in that sense as well, because the students, the whole university ecosystem here need help from experienced founders, investors, and senior business people to really help keep the ecosystem growing and thriving. So if that's you, again, please get in touch. We would love to hear from you. So without further ado, thank you again. Enormous thanks to Cambridge Wireless, Raj for emceeing, all the speakers today. Have a fabulous day, and thank you very much.
Thank you, Tim. Well done. So now I'd like to introduce the next session, which is the keynote called Under the Microscope. So we have Peter Stevens from ARM. Over to you, Peter. Thank you.
Thank you, Raj. Thank you, Tim. And thank you, everyone. Thank you, Cambridge Wireless. Cambridge Wireless and Cambridge Tech Week. It's a pleasure to be here. So my name is Peter Stevens. Recently joined in the last 6 months or so with ARM, where I'm leading our work with the UK government, and previously working within government and also organisations like the OECD. So first of all, welcome to Cambridge. And I was asked to share a bit more of my own perspective on the opportunity ahead of us, the work in semiconductors within Cambridge and also across the UK. So the first thing I really wanted to say is that I'm optimistic. The UK should be incredibly proud of its leadership in this space over the last 30 years, and that is especially true in Cambridge. In that time, only over 290 billion chips have been shipped that rely on the ARM architecture. In the last year alone, that number is over 30 billion. That's an incredibly large number that's quite difficult to conceptualize at 10 o'clock in the morning. So I've done some post-it note maths, and it does work out as 948 per second, assuming that the whole way through, and yes, it was a leap year, or 1 million every 17 minutes and 34 seconds. So in just 30 years, ARM has built the most ubiquitous computing platform on the planet, and now we live in a world where more than 99% of the world's smartphones have chips that deep down have Cambridge's fingerprints on them. And it's not just ARM. Cambridge has a very dynamic and world-leading semiconductor design ecosystem. If you get the train, which many of you have done, I'm sure, and look at the buildings on that road, you will recognize a number of key household names who have sites just near us here. It is truly a thriving and global ecosystem. In addition, the UK companies are also growing very quickly too. We've got Raspberry Pi, who are helping to build low-cost computing to more people around the world, and Pragmatic, who are driving innovation and ultra-thin and flexible ICs. There are many others that show the deep tech capacity that we have here and is the most exciting in the world. So much so that in 2023, the World IPO's Global Innovation Index named Cambridge as the highest intensity science and technology cluster in the world, which is more intensive than San Francisco, Boston, or even Tokyo. It's an exceptional ecosystem, and it's also our home. So at the global level, the supply chain shortages in semiconductors in 2020 really helped to engage and galvanize politicians' views around the world on these critical building blocks that drive every form of technology, and helped to show their importance and how they've broken through. Initiatives like the US CHIPS Act and the EU CHIPS Act promised to close to $100 billion on the issue, and this was just an insane amount of money if you think about the quality of what we needed. The cost to build high-end fabs are astronomical, which cost estimates for nearly 2 nanometer fabs over sort of $20 to $30 billion. We have seen the construction of facilities around the world, and most recently, I think, in Dresden, although there may have been one in the last few weeks, I'm not quite sure. And also, politicians have been focused as well through, 30th of November was a landmark date. We saw ChatGPT was released, which helped AI to really break through into common parlance and to show the illustration of the need for compute and prominence in this new world to really focus politicians' minds. I think in this space, I think the UK can be really proud of its leadership and how it's played to its historic strengths in the security and safety. I think initiatives like the Safety Institute have been really integral to that and have been really developed and manned very quickly. And I think the UK should be really proud of how it's worked, and industry is really recognizing that, and it's already establishing partnerships with its US equivalent so as it can really maximize its impact. And I think the UK should be really proud of that. Within semiconductors, we know the UK ecosystem and the strategy, which we'll talk about a bit later, has 3 key ambitions. Firstly, it's to develop the domestic semiconductor sector, especially in areas of those UK strengths. Secondly, it's about sort of working in partnership with others to help to mitigate those supply chain challenges. And thirdly, it's about sort of protecting its national security, which fundamentally is the sort of obligation of governments. Now, we're really supportive of these ambitions, and our chief architect, Richard Grissenthwaite, has sat on the Semiconductor Advisory Board alongside other familiar faces who I know are in this room. They generously give up their time, and they support Her Majesty's government in this issue. ARM also supports in multilateral forums designed to convene communities across governments with research organizations and industry to develop ongoing partnerships that support and supply trustworthiness of these critical building blocks. Within this first ambition, I think it's absolutely right that the government focuses its efforts to support areas of strengths where the UK can seek global presence. The strategy does name chip design, intellectual property, R&D, and compound semiconductors. And I recognize the following panel will focus on compound and the incredibly advances taking place in materials, so I won't try and do that justice. But I also do think that the UK has a unique opportunity, especially within the increased need for compute, to play to its strengths and to deliver growth for the UK and the country, and assert itself as the foundation of the supply chain of these critical blocks in its design and IP. And I think the key question is how, and I'd really break it down into 4 things. Firstly, it's about skills. And I think the UK, we believe the UK support of education programs that is undergraduate, masters, PhDs within electrical engineering and computer architecture are critical. I think we also know that it starts earlier. So it's about how can we make sure we're working with schools, we're engaging with teachers, and we're helping to make sure that this is a career which is available for all, and not just those who happen to know about it in advance. And I think recent years have seen significant growth in AI and machine learning, LLMs, and I think computer architecture has been relatively deprioritized, and I think that we need to make sure that we help to address this. So to help do that, ARM has been a founder of the Semiconductor Education Alliance, bringing together semiconductor companies and universities to help raise the profile and build resources and help also with a knowledge and skills framework to help identify what are the skills that people need to thrive in this world. Secondly, we need to develop a thriving design ecosystem domestically. I think ARM's model is one of partnerships. We wish to see more companies develop to flourish in the UK in the semiconductor industry when they can experiment, prototype, and grow. ARM continues to support startups with its flexible access initiatives so they can prototype on the ARM architecture and offer free and low-cost options for academics and startups. Thirdly, the UK needs to establish and embed these global partnerships. So Torsten Bell, in his book Great Britain, which I do recommend, argues that the UK now has a unique opportunity to focus its trade on services following our departure from the European Union. I think this would be fantastic to see more, and it's notable that particularly in our relationship with India, and Bangalore in particular, which has a highly skilled workforce in IP and architecture verification, which are both critical phases for us. So our second biggest office outside of Cambridge is in Bangalore, and I know that HMG now has a fantastic new High Commissioner in Delhi, and I'm really excited, and I think this will lead to even stronger partnerships on those essential technologies. Finally, I would love us to do more to celebrate the UK's strengths. The reality is where the UK succeeds is often behind the scenes, not consumer-facing and not with immediate household resonance, although that has been changing somewhat in recent events. Anyone who's ever worked with politicians or just seen the thick of it will know that there's the power of the photo opportunity. And I sometimes hear this called the hard hat and high vis challenge, in that politicians often have a natural predisposition to look for photo opportunities and stories that can gain them that household resonance and breakthrough. There's even a social media account called PPE in PPE, which is people who studied politics, philosophy, and economics wearing personal protective equipment, which is, I thoroughly recommend, but not now. Thankfully, Cambridge graduates have been spared this indignity. We are now going to hear from excellent companies, initiatives that highlight the entrepreneurialism in the region and across the UK. And it's important to recognise that the UK's key successes take place in meeting rooms and on whiteboards and computers. And we have exceptional organisations up our sleeve, and you don't even need a hard hat. So I wish you all an excellent and productive session. Thank you very much.
Thank you, Peter. Thank you, Peter, for that whirlwind presentation. Now we have our first panel session, and this panel is called The Drivers Behind Success. And the chair for this panel will be Andy Sellers. So I'm sure you'll introduce yourself and your fellow panel. Thank you.
Thank you, Raj. If I can invite the panel up, please. Cool. Good morning, everybody. So really pleased to be here. Today we're going to be talking about the drivers for success. So I'm Andy Sellers. I chair the Semiconductor Expert Working Group for UK TIN. I'm an advisor on ChipStart UK, which is the UK's flagship program for generating wealth from the next generation of semiconductor startups. My history is I set up the Compound Semiconductor Applications Catapult, a research and technology organisation. I'm also a chair of Cornerstone, Photonic Integrated Circuit Facility in Southampton. And last year I was honoured to be appointed to the Semiconductor Advisory Panel. And this morning I'm joined by my esteemed panel. So I would like you to introduce yourself, please, and to maybe make some opening remarks. So firstly, if we can kick off with Professor Rachel Oliver.
Hi, I'm Rachel Oliver. I am Professor of Materials Science in the University of Cambridge and Director of the Cambridge Centre for Gallium Nitride, which is one of these famous compound semiconductor materials. I'm also, and perhaps very relevantly in context, funder of Porotech, which is taking porous gallium nitride technologies we developed in my lab and using them to develop new micro displays. So I've got experience of the Cambridge ecosystem in terms of taking a company from very, very fundamental research in the lab and then spinning out into the wider world. And I guess my experience of that both highlights some of the excellence of the Cambridge ecosystem in terms of the support we've received from various university programs, access to investors, access to opportunities to set up premises in this very, very vibrant space around Cambridge, but also maybe some of the shortcomings we see in the UK. So Porotech does much less of the manufacturing that we work than we would once have envisaged in the UK. We outsource a lot of stuff overseas. And I'm quite passionate about the opportunities that semiconductor manufacturing could offer the UK if we were doing more of it onshore and offering really exciting, rewarding, high-skilled jobs to people in the UK population.
Wonderful. Thank you, Rachel. Jamie, please.
Hi, I'm Jamie Urquhart, probably best known for being a co-founder of ARM, but I'm also quite old, and I got involved in semiconductors 40-odd years ago when, I won't take the wafer out, but we had things like these 2-inch wafers, and that was at the time state of the art. I've, subsequent to ARM, been an investor, been a venture capitalist, but more recently I spent a lot of my time with, well, some of your postdocs, starting companies, mentoring on the ChipStart program, which I think is an excellent example of how, with a relatively focused view, you can really make things happen and make changes in the way companies are starting. And I think that the message I'd like to give is that it's very easy to focus on problems, but when I learned to, well, after I learned to cycle, but I read a piece of advice that said if you see a pothole in the road, don't look at it, look round it, and that way you'll miss it. And I think that's what we need to do. It's very easy to moan about, well, there's not enough funding, or there's not enough this, or there's not enough that, but what we need to do is try and work our way around it. If we'd taken the advice when we started ARM that it's going to be impossible, we wouldn't have had the first speaker. You know, lots of things are possible, and some very exciting things are possible. And we then need to take them and commercialize them and really make them successful around the world. It's a global business we're in.
Wonderful, thank you, Jamie. And Nikki, please.
Yes, good morning, everyone. So my name is Nikki Athanassopoulou. I work for the IFM Engage, which is the knowledge transfer company wholly embedded with the university, within the engineering department at the University of Cambridge. So a part of my background, which is a little bit on exotic semiconducting materials, organic electronics, last year I was leading the study on behalf of the Department for Science, Innovation and Technology, the UK government, on what sort of infrastructure basically the UK needs for the semiconductor space. So together with Andy was part of that consortium, Sean, which is in the audience, was part of the consortium, and Charles and many other people. We ran a study of, it lasted 10 months, and I think we managed to talk to about 180 different organizations across the UK, both academic and the majority of industry, just to understand what their needs are, what their ambitions are for the future, and come up with recommendations to the government that actually are representative for the UK PLC predominantly, but also the academia. So I come to participate in this panel, I think, on, you know, sort of with that knowledge at hand of what happened last year and what sort of we learned from the industrial engagement and the academic engagement.
Brilliant, thank you. So the panel's about the drivers for success. Now I've got some questions to sort of open up the discussion, but I'm really keen to hear about your questions as well. So if you can have a think about what you would like to ask, and after my opening questions, perhaps we can go to the audience. So last year, the UK government published a semiconductor strategy. It was launched in the Catapult, actually, on the 19th of May. It kind of identified, it fundamentally said UK can't do everything on its own. In fact, it said no one country can do everything on its own. But it did say that countries ought to specialise, identify their strengths and specialise. And in particular, in the UK, it identified strengths in research and development, design IP, and compound semiconductors. So if we can't do everything on our own, I guess my opening question is, how do we form partnerships? Where are those target partnerships? How do we select the countries? What would be your sort of top areas for partnership? And what is the appropriate form of partnership? Perhaps, Rachel, if I go to you first, because I was just thinking about Porotech, and you were saying that at the moment you're kind of, Porotech, my understanding, is a spin-out from the university doing and it was taken out of the university to focus on growth. But you did say that you're kind of offshoring a little bit, perhaps too early. So I'm wondering about how are you selecting those partners, and what is the appropriate form of partnership for you?
So for us, as it stands now, we have a great deal of activity in Taiwan. So Porotech has a Taiwan office and a significant team out there. And we've maintained a key aspect which relates to our IP of our manufacturing in the UK, but we get material in from Taiwan, we do the Porotech bit, it goes back out to Taiwan. So that relationship with Taiwan has been very, very important for us. And actually, I think that has been manageable. Yeah? I think we had concerns in the early days both about whether we could get the kind of bespoke materials that we needed. And I think part of the solution to that has really been that we don't just like order stuff from the big foundries, we have our own people embedded there. And I think that kind of really deep involvement in those partnerships rather than sort of doing it in a hands-off way has been very, very significant for us. And I think we also had, and I think potentially retain at times, concerns about how we kind of ring-fence our IP when we are engaged in depth with these very, very big global players, including people like TSMC. All of that said, though, I mean, there is a fantastic ecosystem out in the Far East. They can do brilliant work. The materials we get from them are very high quality and at a very reasonable price, given the complexities, if you like. So there's a huge amount of opportunity in that engagement, but we've also seen, sort of looking across the Far East more broadly, that there is nervousness from government about engagement, particularly with China, and that whatever the rights or wrongs of that situation, we have to be very, very conscious of those geopolitical issues in terms of how we step by step go forward.
Sure, thank you. Jamie, if I can turn to you next. So just thinking of your experience with ARM and the other companies that you've worked with, and we heard from Peter about, you know, the second highest design facility being in Bangalore. And I'm aware that ARM, to Rachel's point about having an embedded team, I'm aware that ARM have had an embedded team in Taiwan for some time. So what is your view on how we sort of select those partnerships and how they work, and where there might be risks that we need to mitigate, as sort of Rachel was talking about, sort of IP and that sort of thing?
Yeah, I guess right at the start of ARM, 1990, we took the view that the world, the semiconductor industry was a global industry, and we were going to have to play within it. We couldn't just hang around in a little barn in Cambridge and sort of do great things. We were going to make our success with the way in which we engaged around the world. And frankly, that's been a really enjoyable part of the whole journey, is working with different countries, working with different people of different cultures, and not just learning about what they can do in electronics, but things about how they live, the work they do, and how they socialize. I think that if you're going to build a partnership, though, you've got to think true partnership. Is it a 1 + 1 is greater than 2 partnership? Are you actually both benefiting each other? You've got to build trust in terms of who you partner with. We used to have a saying that we should do what we're world class at, and we should outsource the rest. Not because that's where we create the best value and the most value. And in fact, ARM's first steps in India really were with Wipro. We formed a partnership with them, and they would do design of parts of the peripherals and how they worked, and whilst ARM focused on the core and the CPU and such like. As that built, ARM has now, as we heard, developed a facility, its own facility in India. But I think we need to be always foraging forward, looking to where opportunities lie. I talked about, I've been in the industry for a long time. We've seen a billion-fold increase in complexity. New opportunities arise all the time and constantly, and sometimes we need to think of where the places we want to work that might not be seen today as the best, but have the appetite to really grow and succeed. And I think that being open to opportunity, being open to not necessarily working with what seems to be the most commercially successful, but technically successful as well, or up-and-coming technical success is really important. And the whole thing goes backwards as well. So again, working with university departments and helping build the relationships that go right through, because ultimately partnerships have got to end, they're going to start with research, and they've got to end with commercial products that people around the world want to buy. And in the middle, there's that slightly difficult bit of how do you also fund all of this activity as you get there. And these things, it doesn't have to be a highly structured process, but it does need to be a continuous process of various partnerships as we go through. And seeing Sean in the audience, I can't help resist. One of the things they're doing is they're bringing venture capital and making them aware of the opportunities in the semiconductor world. An example of the sort of partnership that we're capable of producing. But it's got to be a two-way. It can't just be a one-way. And you've got to build trust and momentum in making it happen. You can't just, as some companies will take ideas, make it successful, and then leave you adrift. You've got to build things that are going to stand the test of time. And that's really important.
Thank you, Jamie. And ARM certainly has demonstrated the test of time with the 30 billion chips that Peter was talking about earlier. Nikki, so I'm just wondering, the work that you led on with the Institute for Manufacturing and sort of surveying those 180 organisations in the UK, did you get a sense of where you thought the partnerships might work. So in other words, the UK companies, the academics and the industry, so where the bits that we ought to do. But to Jamie's point about trust and building something which works both ways, did you get a sense for where the bits that we ought to be doing and how those partnerships might work with India or Taiwan or other regions?
I think there are two things here, I think. One is, as Jamie mentioned and Rachel, partnerships within individual organizations, companies, let's say, collaborating with other companies. And that, of course, is a private matter. You know, they decide what capabilities they have, what they want to outsource. The other aspect, of course, is on a national level, you know, what the governments do and how they facilitate with partnerships the national companies and academic institutions, you know, to do better work or scale up faster and so on and so forth. And these are well, not completely different, but slightly different considerations to take into account. And for example, I know the UK government is actively seeking partnerships with Japan, I think it was published already, and other Asian, as a manufacturing partner. So there were sort of some potential collaborations and discussions in that format, and perhaps other countries as well. And this, I think, is all, I mean, partnerships are important because no single country currently, as it stands, internationally, can do everything in-house, even Taiwan with, or sort of South Korea. So they need to partner with other countries, you know, to make the semiconductors operate. Now, the question is how do we select these partners? And the question of trust, I think, is fundamental. Even with an ally, let's say, or a long-standing partner like the United States, part of the study that we're doing, what we found out talking to companies is design, for example, were more or less is very constrained space. There are only 3 major design companies that, you know, you have sort of the usual suspects. 2 of those major design companies are US based. The US, which is a proven ally and partner of the UK, have decided for military sort of or defense purposes to restrict the use of the software. So the US companies, private organizations, cannot necessarily collaborate with UK companies for certain design aspects. So you need to be quite careful of how you partner, and even with established allies and partners, situations change, you know, national priorities change, and then that has an impact and a ripple effect for the UK companies. So maybe, if possible, it's not always possible, but if we could not single source, not just have one manufacturing ally, one design ally, and one sort of scale-up ally, let's say, or partner, maybe that would be more wise approach, I think, to de-risk, let's say, the exposure of UK companies to global changes.
Great, thank you, Nikki. So I'd like to sort of move on a little bit, sort of supporting, thinking about the support for startup companies. So ChipStart UK is UK government's funded by DCIT. We have Sean Redmond, who'll be talking a little bit about it later on the panel. It's the UK government's flagship program for getting new companies started. I've got a question here about what is how does infrastructure support? What is the value of infrastructure? How important is that for these sort of new companies which are coming along? And how does that help sort of with an ecosystem help them to grow and access those markets? So perhaps if I can start with you, Rachel, as a sort of a representing Porotech.
So I think. So we spun out Porotech originally in 2020, and with a desire really to have multiple stages of manufacturing process. And you know, you're never going to be able to do everything in the UK, or to be honest, everything in any single location necessarily. And I think what we found at that stage was that there was a real lack of will amongst UK-based investors for capital expenditure, bringing even small levels of serious infrastructure into the UK, and that very much influenced our business plan at the time. My impression is, and watching other people's journeys and ChipStart UK, that actually across the last few years there's been a real change of mindset, and that will progress. I think that one thing that we've seen that's going to be a huge factor is the fact that semiconductor is now part of the remit of the UK infrastructure bank, so that then when companies at a certain stage, and that is, you know, some distance into the scale-up journey, really, it's not a startup investor, but when they're reaching the point where they do want to develop a larger set of infrastructure to do more manufacturing in the UK, that's something the UK Infrastructure Bank can get involved with and really support, and we've seen that with Pragmatic, for example, very recently. And I think that's going to give an opportunity for the UK to draw greater benefit from what is actually a really vibrant kind of selection of people with really exciting ideas that they're trying to push out into the market, but which historically have perhaps, like the IP has been in the UK, but the benefit of that IP has often gone elsewhere because we were doing so little manufacturing. Now we've got, with these UK Infrastructure Bank and a slightly changing ecosystem, much more opportunity to really make stuff here. And I think I'm excited about that going forward.
That's great, thank you, Rachel. So I guess the reflection there is that the infrastructure is helping to extend the investment, and it's helping to kind of keep the investors on the journey, and the infrastructure bank is kind of part of that ecosystem. So if I can turn to Jamie, so that sort of question about infrastructure and ecosystem supporting the startup journey. Are there any gaps you see that could be helped, or are, you know, particular things like the infrastructure bank? How do you see the ecosystem supporting the startup journey?
So I've probably been involved with startups the last 20 odd years, mentoring them, programs like Ignite and Impulse out of the Maxwell Center. ChipStart focuses on a particular market segment, which I think is actually one of its strengths. It takes a more holistic view of what you need to have happen. I believe that business is holistic. You can't just focus on one thing. You've got to look at the business in the round and what you're doing and why you're doing it. As I said before, focusing on what you can't do is, in my mind, not the right way to move forward. Focus on what you can do and how you're going to drive it and what you're going to make happen from it. I'm not here to whinge, and I think that what we should be doing is saying, what can we do better? And you always want to ask yourself, what can we do better? If something doesn't work, that's a learning. It's not something to beat yourself up about. It's about then moving forward and doing things better and growing from that. So we need to look at what the strengths are. But I also think from a UK strategic point of view, what is it we're trying to achieve? Where are we trying to go? And where do the things we fit into that? So there are some, I think, existential issues we're having. Education, the educational divide, the economic divide, things like climate change. We've got lots of great research taking place in the universities that will aim to, or potentially produce ways of mitigating and fixing those problems. We've got the demands of security. All of these things, I think, lead into what are the routes that we can take, that they can take to build and get known. And obviously at the very first stage is this idea that we don't have to license. I know this sounds strange coming from me, having been a founder of ARM, but we don't have to license everything out. We can actually build things. I invested in a company probably 20 years too early, but they found the best place to get PCs manufactured was just down the road because they got a much quicker turnaround, their level of quality was great, and it wasn't that what they were getting elsewhere was bad, it's just there was a huge communication cycle and delivery cycle. So I think we also ought to be questioning some of the things we take for granted, because why do we take them for granted? I mean, it's like there's a whole bunch of elephants that we don't want to address and we don't want to deal with. And if we're going to build really successful companies, it's the companies that do things that bit differently and make progress in different ways. And so we don't just have really creative and clever people doing PhDs. We have clever and creative people in terms of how you do business and what you do business with and where you're going to work and when you're going to operate. And ultimately, all of these things have got to be for the benefit of people who live in the UK.
Brilliant, and I really liked your opening comments about sort of if you see a pothole, don't look at it, go round. And I feel where you're coming from is that the UK's entrepreneurial mindset, so it's not just about being clever technically, it's about navigating a landscape, and perhaps that infrastructure question is partly about having entrepreneurial people around you and investors that are thinking entrepreneurial, because it isn't a straight journey.
Yes, not giving away any secrets, but almost every presentation I see that's come out of a science department is like watching a paper being presented, not about telling me what the benefits are, what it could be like. And so it's getting that mind switch. And this isn't just coming out of departments. I mentored, or talked to someone yesterday, my age, and it's like I've just received a presentation on all the technology and not about what the benefits are and what it will do and why it's a good thing to have. And I think that is a mindset that's also got to be encouraged to change, not to not do the science, but to understand then that the best way to communicate it is not necessarily detailed on the science, it's what the advantages are and what we can do with it. I've seen too many presentations where at the end of it I'm thinking, but what do you sell? That's a pretty fundamental question.
Brilliant, thank you. Nikki, if I can just round off on the sort of the infrastructure question about how that might support, the next generation of semiconductor companies, maybe sort of reflecting on some of the work that IFM and we worked on last year. Were there any particular things that we felt that came out from that study where, if there was something, was there some sort of mechanism, some block, that if we had a piece of infrastructure, whatever that might have been, it would have enabled a whole bunch of companies to go forward? Can you think of any examples?
I mean, for silicon, we looked at 4 classes of materials last year. So silicon was like the standard classic one. And I think that, because it's a mature industry, silicon has been around for, 40 plus years, there is international capability, not necessarily within the UK, but you could potentially do your prototyping, using some intermediaries or foundries and so on and so forth. But the infrastructure thing is particularly pertinent for 2 things. One is for new materials, like compound semiconductor materials. So there is not really sufficient, within the UK in particular, pilot lines. So okay, you did your 4-inch device or whatever, you small wafer, in the lab, you maybe run 100 samples if you're lucky enough, and you can do that in a university setting. And then what's next? How do you scale that material then within the UK and maintain perhaps even the volume, some sort of volume work within the UK? So this doesn't exist in the UK at the moment. At least for the materials we looked at, which was silicon carbide, gallium arsenide, and gallium nitride. So these are the 3 key ones that we looked initially. And the other thing that doesn't exist, and I think it should be some consideration if we want to really maintain some leadership in semiconductors, some sort of knowledge in semiconductors, is advanced packaging. Because the silicon is going down and down in nodes. Different ways to package now silicon devices will emerge, and investment is happening internationally in this space. We do have capabilities and knowledge from a university background or level. And the question is what the UK wants to do in that space. So infrastructure for advanced packaging, it doesn't exist extensively. It exists within specific companies that we discussed during the study, but also this is quite isolated. They are not open foundries. You cannot, as an outsider, as a spin-out, go and create advanced packaging solutions, in the UK at the moment. So I think these 2 particular items that could be considered. And if I want to say specifically then, generally for startups in the UK, skills is also an issue.
Skills.
And we're not talking about just getting the PhDs to do the smart material science, which is very important. I'm not downplaying that, of course. But also even process skills. How do we actually, okay, we got this material, we managed to do our little wafer. How do we actually create a manufacturable process of that material? How many layers we need to put, how we put sort of different species and whatever. So, and this we need to grow somehow as a country. I think we need to seriously invest money and effort into developing these skills within the UK.
Great, thanks, Nikki. So I've got quite a few more questions I could ask, but at this point I'd like to go to the audience to see, do we have any questions from the audience for our panel, please? We have one down the front here. If we can get a microphone to this chap in the front. There we go. Yes, please, your question, sir.
Okay, I've got two very different questions, so I'll start with the less contentious one. One of the learnings from Tech Week on Monday was small companies should find a big friend, companies to partner with. Jamie, when you were starting ARM, your partners were very much bigger than they are today, Olivetti, and a very much smaller than they are today, Apple. What did you learn from that, and what would you do differently?
So, Acorn basically had commercial problems. So the fact is that Olivetti were an investor. Originally, they thought that Olivetti were going to be helping them sell their computers, and it turned out that they weren't. We did, my group collaborated with Olivetti's chip design group, and we actually sold them a set of standard cells. So we made a very little amount of money. But in many ways, Olivetti didn't know they'd got ARM. It just was some side note of interest to them. I think what really happened, the significant step, was getting Apple. Apple invested in ARM, but we had to build a chip for them. We had people, this sounds terrible, forgive me, academically arrogant as they did, and they got on like a house on fire. And one of the key factors was Larry Tesler, who was running the Newton Group. This was a product they were building. And when he came to ARM, he thought about ARM and supported ARM. As an individual, he was incredibly beneficial. We had a variety of chips, ARM1, ARM2, ARM3, and he said, well, you don't want to call the next one ARM4 because that's like the Intel 486. Call it something different. And we did, and it sounds stupid. You don't think engineers are that stupid, really, but it worked. It transformed them. And this comes, so just kind of, the key issue here is businesses do business together. It's people who really make those partnerships work. And so what really made it work was that individual and his team working with our individuals and the team to make it successful.
Brilliant, thank you.
What did you call ARM4?
Pardon?
What did you call the ARM4 chip?
It got called ARM6.
Skip two.
Yeah. Great, thank you. Sean in the second row there, please. There's a microphone.
Thank you. So the UK has the third largest semiconductor research base in the world today. And we're facing a semiconductor industry which is the third most profitable industry in the world, and we've got 16 of the top tech companies which are now out of the top 20. They're really semiconductor companies. So we've got UK sitting with crown jewels that the industry, global industry really needs, and we've got a new government that's come in focused on an industrial strategy push. How do we make our semiconductor research base relevant to that discussion where we can benefit as an industry in the UK? Because it's such a profitable industry, we should be proliferating significantly more of our ideas and commercializing them. So I'd like to ask the panel to advise government on that.
Brilliant question. I've got some thoughts. So do you mind if I sort of put a couple of thoughts in, and perhaps then we can come back and respond. So I was with the Secretary of State yesterday, Peter Kyle. He gave an address. Whoops, that's my glasses falling on the floor. He gave an address at the Campaign for Science and Engineering, a really articulate address. I can see exactly where he's coming from and his passion. So he's really interested in roots into education. and how that benefits society in general, how it benefits regions. He was in Glasgow looking at the satellite industry and was extremely impressed with the fact that we make more satellites in Glasgow than I think he said the rest of Europe. And I believe he's going into South Wales to look at the semiconductor cluster in South Wales. So he's very interested in the region, but he's very interested in people getting into the industry. So a little bit about what Nikki was saying about the importance of the skills. And I think the route into his thinking is to articulate why this is beneficial for the populace in general. How is it going to benefit the public if we're getting people into these high-paying jobs? I think that's kind of the thinking there. I don't know if any of the other panel want to add some comments.
I can say something. I mean, I think skills are very important. My personal view, this is not from the study or whatever, is that you need the infrastructure as well. You know, so you can learn so much by just doing things in the lab or in a small scale, but ultimately, you need to combine the two to actually make a difference. It's like saying, learn to read, but I'm not going to give you any books. So you're going to learn only up to a point, okay? Or learn to drive with simulations. You know, you need to have hand-to-hand both some sort of, you know, relevant infrastructure and the skills and the schools and everything, and the funding, to be honest, behind to make it all work and click.
And I think from a skills point of view, it would be very easy for government to imagine that we only need kind of PhD educated people and that this is not something that's relevant to, you know, the vast majority of the UK population. But actually, if we look at like the people that we're trying to recruit both in the university and outside, we're short of technicians, we're short of people, who have the hands-on skills, and we want to educate people and draw people up into those roles, which will then provide opportunities kind of across all sorts of people with different needs and different things to offer as well.
I think also we need to think about electronics isn't just about a bunch of chips coming out of a fab and being sold. It's what do they go into? And there are some very interesting products being developed around the world. The UK has some of the skills, but do we have the desire? Are we really wanting to build significant companies on a significant scale? Forgive me, I'll use another example, an ARM. We talked about BHAGs, big, hairy, audacious goals. If you're not going to try and achieve your moonshot, you won't achieve your moonshot. And even if you try and achieve it, it might be a disaster. But I think to some extent we're sometimes worried about really shooting for those big goals and then getting them funded and then really building them. It still does happen, but maybe it's just a question of numbers of people. But if we're going to play to our weight in the basic skills and the basic technologies, we ought to be able to then put things together. And we don't have to build them. We can outsource a lot of it, but Apple outsource a lot of their manufacturers, but they own the phone. And we could do that. I'm not sure I'm the person to really suggest how we're going to do it, but I think we do need to do it. And that would then draw in, it would be a customer base for our tech companies.
Great. So the combination of skills and infrastructure. We were reflecting earlier that there was some big infrastructure investments in Scotland and the northeast about 30 or 40 years ago. And you know what? They're still there and they're still sort of seeing the impact of that. Now, I think we have time for one more quick question. Go to Aidan, please.
Thanks. The one question I have is all maybe a comment, actually. When we keep talking about UK strengths, let's not forget that one of the UK strengths is financial. Now, our service sector is very good. Now, how we utilize this? Now, the reason I'm thinking about that is because you all heard of the big trend in semiconductor market. It would revolutionize, if I try to not to exaggerate, is a chiplet. Now, imagine within 3 to 5 years, for my money, the chiplet will dominate everything. Everyone can create chiplet as a component. Now, how we utilize UK financial strengths to capture that? So I think that's sort of my thoughts, really, yeah.
Great, thank you. So we do have quite a short amount of time left, so maybe a very short response. Where is the UK strength that we're going to be able to tap into this new emerging approach of chiplets sort of replacing? So perhaps from Porotech's perspective.
I mean, maybe actually from my university perspective, I think that we've seen that there's huge UK strength in these kind of chiplets and heterogeneous integration. And the UK has historically been a real innovator in novel and new materials. There are new semiconductors coming through. And I think what I see as really important is drawing those new materials into these heterogeneously integrated systems as giving us real opportunities for new technologies.
Great, thank you. Any last comment?
Just briefly, we're not just good at, we're very good at attracting talent into the UK. You know, the universities are places that people want to come and study. And that's something else that we still need, I think we need to continue and draw upon, because that way we will and can compete with the world.
Final word from Nikki?
Yeah, chiplets and finance, I think, was the combination. I mean, we did say, you know, the finance is an issue within the UK, especially for large investments. I mean, for seed funding, it's probably not as difficult. We need to solve it. I don't know the exact solution to, but I think it needs to work hand to hand. And chiplets is an area that we need.
From the audience, if we can give the panel a round of applause, please.
Thank you, Andy. Thank you, panelists. And we're going to go straight into our second panel. And our second panel is exploring the area of emerging technologies. And we'll just give a moment for them to come up. And it's going to be chaired by Charles Sturman. So a round of applause for him, please. When you're ready.
Cheers. So I'll just wait for my panelists to come up on stage. So thanks, Andy and team. That was a really interesting session, I think. So I'll introduce myself. I thought I'd say a few words and then I'll ask the panel to introduce themselves. So I've just written this down. 35 years I've been working in chips, which is crazy, as have many else in the audience, I'm sure. So my background is chip design in wireless, process technology. I've worked in big companies, small companies. I was at Acorn, actually, and later on in life I was at ARM. And in fact, most of my working life I've worked from Cambridge, but I've spent a lot of that time traveling around the world, talking to various companies, trying to sell our technology to them. I joined TechWorks just under 2 years ago, as my wife told me to do something. Stop moaning, do something. So there we are. And TechWorks is the UK trade association for deep tech and semiconductor companies. So we have 300 member organizations, from startups through to big global companies. And our mission really is to try to grow the UK sector from chip design to chip manufacture to embedded system design, automotive, electronics, power electronics, and even AI. So I thought I'd read a few thoughts out to you about the UK landscape with respect to semiconductors. You may not know this, but when I learned this, I was quite shocked, frankly. We have 20 commercial fabs in the UK. So there are 20 physical locations, companies that make semiconductor chips, and they sell them commercially, obviously across the world, because it is not a one-region market. There are 7 academic or research institute fabs, and in fact, I'll just call out Cornerstone as one example out of Southampton, which is a research institute fab, but it's actually quasi-commercial, and they do a lot of prototype, low-volume pilot manufacture of silicon photonics. We have, this is another astounding statistic, we have in fact more than 160 companies in the UK engaged in design. And Sean's doing a good job there. He's added another 20 startups to that figure, more than 20 startups, through Silicon Catalyst and also the Chip Start program. So we're in not a bad position in the UK in many respects. I just want to call out a few UK success stories, and many of these are actually Cambridge companies. So ARM we've heard about, Cambridge Silicon Radio, CSR, who basically invented the idea of doing standard bulk CMOS RF, and therefore produced a single chip radio transceiver, which was Bluetooth. They're still around in a new guise in terms of Qualcomm, which has all of its Bluetooth stuff, or most of its Bluetooth stuff here. Imagination, XMOS, IQE, which is down in Wales, which is epitaxial growth on silicon wafers. They don't make chips, but they're a massive global supplier of epitaxial growth on wafers. Some past companies you'll have heard of in Cambridge, Verata, Alpha Mosaic, and I just wanted to refer back to Stan Boland yesterday in the debate. He gave a very interesting potted history of GEC, Marconi, Plessey, Semiconductors and GPS. But again, although those companies are kind of long gone, there is a long heritage in the UK still, especially, for example, in Bristol and the southwest. So finally, it occurs to me that if you go back to the 70s, 80s, 90s, semiconductor was an increasingly more interesting way to deal with complexity in circuit design. Nowadays, semiconductors has become fundamental to our way of life. And indeed, the purpose or the title of this panel is to talk about how semiconductors is influencing and driving emerging technologies going forward. I'll just make one last comment. The Global Semiconductor Industry Association forecast says that this year we'll have about $600 billion revenue from semiconductor sales. In 2030, which is in 4.5 years, or a bit less than 4.5 years' time, that will be more than 1 trillion, something like 1.1, 1.2 trillion. So the semiconductor opportunity is not going away, it's actually accelerating. So with that, I'd like to introduce the panel. I'll let you do it yourselves, so I'll start with Andrew Flewitt.
So hi there, my name's Andrew Flewitt. I'm a Professor of Electronic Engineering and Head of Electrical Engineering in the Engineering Department here in Cambridge University. But my sort of sideline is I'm a co-founder of Soric Sensors, which is a startup between Cambridge University, Warwick University and the Polytechnic University of Madrid, making gas sensors for indoor air quality monitoring, but also the agri-tech industry as well. And do you want us all to sort of say a few thoughts
Please
as
do.
well
Yeah,
at this
yeah.
point?
Yeah.
So, the thing that strikes me, that the way we live today compared with 50 years ago is completely changed by semiconductors. You would not be sitting here now were it not for semiconductors. You probably wouldn't have found out that this event was even taking place. If you had, you probably wouldn't have found your way here without the sat-nav that got you here. And you wouldn't be here listening to me now because this amazing audio-visual system wouldn't be sort of projecting my voice to the back of the hall. It is absolutely embedded in everyday life. And as Charles said, the rate of development is enormous. It's far faster now than it was 50 years ago. So imagine what life is going to be like in 50 years' time and the opportunities that are there by investing in semiconductors now to make that happen. So I think there's an amazing opportunity that we currently have. And actually the UK is very well placed for that. We have an amazing academic base, which is a real powerhouse for generating new ideas. We do have a great design space here as well. We've got companies like ARM, as we've already seen, but a whole wealth of knowledge in design here in the UK. And perhaps where there's an emerging opportunity is actually in that manufacturing side, that if we can actually bolster that as well and do that in partnership with other sort of trusted partners globally, and I think there's a huge opportunity for us in the UK. And my final thought on this is that actually at the end of the day it boils down to people. And actually I think that Jamie's sort of comment earlier on about partnerships all being about people, it's really important that we have really well-educated people who understand the complexity of semiconductors, understand that hard academic sort of nitty-gritty, but also understand that side of how it's applied in the real world, how you design with them, how you manufacture with them. And there's a real opportunity there, I think, for working between academia and industry to make that all come together.
Richard.
Thank you. So I'm Richard Murray, the Chief Executive and co-founder of Orca Computing. So Orca builds photonic quantum computers. So photonic, study of light, we build quantum computers based on single units of light, single photons. My background's all over the place, in and out of government. My last job was working for Teledyne ETV, so one of the companies probably included in your list making silicon-based photon detectors and things like that. So I guess Orca's position within semiconductors is quite new. So we have several of our products out with different customers. So I think we're quite unique in the quantum landscape of actually having shipped quantum computers now to 5 different customers, large high-performance computing centers. And our job is to find how you make quantum computing useful to large-scale high-performance computing. Our systems are predominantly based on off-the-shelf telecoms, so telecoms type devices. And for a long, long time, we were noticing that we were reaching the limit of what you can buy with off-the-shelf telecoms. So we were partnering, we were entering into developing our own semiconductor platform in order to create and manipulate light at the smallest level, single photons. And I mean, our story is that we found that was productive. I'm personally the believer that photonics is entering this really exciting new era of being integrated. And by the way, that integration isn't just relating to silicon photonics. There's a whole world outside of silicon photonics that I'm talking here. But there is this sort of huge exciting movement happening of photonics becoming integrated. And I mean, frankly speaking, Orca was collaborating a lot to do some of that work and finding that we weren't owning enough of it. So over the new year, we actually acquired a Texas-based semiconducting company they spent 6 years building integrated photonic circuits using silicon nitride. And through this acquisition, we were able to bring in-house their design, to a certain extent, fabrication and packaging expertise. So it's quite nice now to be sitting here as a semiconductor company, which we weren't 12 months ago, and happy to talk, I guess a believer in the global semiconductor supply chain. I can talk a little bit about the UK's position in that if you like, but in this case, Orca chose to spend a lot of our time out in Austin as part of our global operations.
Richard.
Hi, good morning everybody. I'm Richard Price, co-founder and CTO at Pragmatic Semiconductor. So thank you for a couple of shout-outs already from various speakers. I also, like Andrew, wear 2 hats. So my other role is I'm a non-exec director at the Henry Royce Institute, which is the UK's National Institute for Advanced Materials. I think that's probably going to be a theme of discussion for the panel as well. So what do Pragmatic do? Well, we've developed a process to manufacture flexible integrated circuits. So these are essentially wafers that are inherently flexible and thin. And we've set up manufacturing in the UK to scale that up. And it was mentioned earlier that one of our lead investors in our last round was a UK infrastructure bank to help us to scale that up in the UK. These are currently being sort of used for item level intelligence, so being able to cost effectively deploy connectivity to everyday items and allow you to have more and more items connected to the internet and start to push out some of the decision making around things like sensing and so forth further and further out to the edge. Just picking up on a couple of themes from the previous speakers on the panel, in terms of the influence of semiconductors looking forward, I can see 2 things maybe to pick out. We were hearing earlier about sort of generative AI and the acceleration of that, particularly in the last couple of years, and we can see some of the benefit that brings, but I think also we need to look at how we do that responsibly and sustainably. So you look at the energy demands of trying to scale up Gen AI, it's, some of the figures I saw recently at the GSA event, it's going to require a huge investment in terms of the energy demands at the scale of the kind of total demand of India and Germany combined to be able to do that over the next 10 years. So we have to look at different approaches in terms of how we continue to develop semiconductors. So things like low loss electronics, more sustainable manufacturing processes are going to have to be key, doing that in the right way so we can responsibly move forward in the way that we deploy this and bring the benefits that can deliver to society. The other area I'd pick out is around healthcare. So we've seen over the last 10 years, in particular, proliferation of connected devices that are giving us all kinds of signals around the body, and indicators of health condition and so forth. We've been so successful over the last couple of hundred years of eradicating, particularly in the Western world, communicable diseases. What we're now seeing is some of the chronic diseases, and I think electronics alongside things like genomics are going to have an incredibly important role to play in moving towards personalized healthcare and really starting to address and detect at early stages things like cancer, and to combine that with genomics and personalised healthcare interventions, and again doing that in a way that's cost effective and scalable.
Thank you. Simon.
Morning everybody. I might have just crept into afternoon almost, I think.
No, not yet, still morning.
Feels like afternoon. Wonderful to see you all, and it's great to be here today. Some great points made by the panel here, and I'll pick up on a couple of them in a minute. But just as background, I'm CEO of a company called Paragraph that's mainly located just up the road in Huntingdon. I spanned the company out of the university, same department as Rachel here, who was speaking before. And Paragraph's technology is based around new materials, particularly two-dimensional materials, and for now, around a material called graphene. So we make the world's first scalable graphene electronics. By doing this, we're bringing an advanced material into the spectrum of semiconductor electronic technologies, and there's a really important reason for this. Today, we had some great points about where semiconductors are going in the world, how big the market's going to be, how much we're going to use of semiconductors, and of course, now new technologies using more and more power in order to get the performance you want for your applications, whether that's in AI, whether it's computing, doesn't really matter. The problem is the energy draw, and unless we change our thought pattern on how we're using materials, we are not going to solve that problem. So Paragraph produces graphene, as I mentioned. That material today, when we put it into chips, takes 1,000 times less energy than a silicon chip. This is really important for the future of technology. As we put more and more chips into more and more processing applications, we have to find a solution if we don't want to burn the world. It's that straightforward. We're not going to create the energy we need. We're going to have to look at how we use energy. And that's what Paragraph is driving towards. So to pick you up on your point, Charles, Paragraph is about 6 years old now, and it will be the 21st fab in the UK. We have our site opening just up the road in about a month's time. So it is going to be a chip fab. We will be making chips, but with one big difference. It will be the first two-dimensional chip foundry in the world. So we're pushing out chips that will fundamentally change how we look at semiconductors, how we look at future tech. Because when you put two-dimensional materials into semiconductor structures, they operate very, very differently. And therefore, in the future, design companies would be looking how you design for different dimensions of materials, not just how you make different architectures of chips. I think the influence of semiconductors on emerging technologies is a really important subject for the UK government, because we heard before from the panel, we can't do everything. And the question is, what do we do? And there's several companies sat here right now doing incredibly different things. I hope we can do them all. The question is, how do we get the most out of what we can do in our innovative spirit and our entrepreneurial spirit, and retain that value here in the country? So I'll leave you with a thought before we move on to the commentary. The government keeps telling us that we've got a 22 billion gap in funding at the moment in the country. I think the four companies sat up here could fill that gap if we were financed properly in the next 10 years. So let's think about how we push the country forward and generate GDP from the technologies that we're great at doing, because that would be a challenge.
Thanks, Simon. I'm going to ad-lib a moment. You've just reminded me of something. We put a paper out just before the election, and there was a comment in that paper about NVIDIA. So NVIDIA, obviously one of, or potentially the biggest company in the world, their tax bill last year, I think I'm right in saying it was about $10 billion. That's half of that black hole right there. Just one company. I mean, okay, I'm not saying necessarily we would have an NVIDIA in the UK, but...
Why not?
Why not? Indeed. Yeah, four NVIDIAs here, right? So really interesting points coming out of that. I wanted to try and tie two things together here, and I'm going to follow on from the political commentary myself. We're really good at innovation in the UK. Jamie made a really important point earlier about making stuff, or perhaps I should say selling stuff. Okay, you don't necessarily have to be a fab. You could be a fabless company and you have production manufactured elsewhere. But either way, and in fact, on the panel here, and I'm really interested in what you told us, Richard, about why you bought a semiconductor company, right? So I think, especially in the emerging semiconductor new materials field, design and manufacture come hand in hand, right? I think the UK is good at innovation and ideas, but how do we scale and bring those ideas to market? And I'm also conscious of the phrase supply chain. And I think I'll start with you, Richard, of course, because you gave us that example right there.
Yeah, I think it's a really good question. So, I mean, I think it's clear that the supply chain for semiconductors is critical. And I would actually add that being very specific about where you sit in the supply chain is also critical. And that applies for a company, and I can talk a bit about AUKUS and our perceived positioning, but also for the UK. I think it was mentioned, I actually don't believe, I think one of maybe the challenges of UK policy, not to get into this too much, but is just trying to do everything. And it's just clear that we're not going to do that. Totally clear. So what specifically are we going to do? But coming back to the company perspective, so we noticed that we needed better devices within our product, more performant, lower loss, higher speed telecoms type components. We spent a long time collaborating to try and bring those components to market. Collaborating with European players, IMEC and Ligentech and things like this. And I think I mentioned that we were just finding that we didn't own enough of that, which had two consequences. One, we don't own it, so we can't ultimately profit from those components, and it was clear that those components were going to be offered up to the wider market and our competitors. But secondly, and maybe more pertinently, we also had no ultimate control over the direction of those components being developed. We had to assume that we would be aligned with the overall direction, the overall research agenda for those larger companies. And for what we were trying to do, it was too innovative for that. So, sorry, coming back to your question, we bought this company. The company, in my view, is particularly impressive because they don't try and do everything. They work within a larger facility. They license it, they buy in certain parts of certain components which they can't do themselves. They don't do the growth, they buy in wafers and things like this. And they also collaborate on packaging and things like this. And so I think it's, to get to maybe the point I'm trying to make, we particularly honed in on what we needed to do for the company, which was the development of new materials and the making those a product that we can use. And then we leverage what was available to us through this acquisition in terms of the knowledge of the supply chain we could leverage to do that. And we stick to doing just the thing that we need to do, if that makes sense.
Simon, back to you again. How do you scale the business up? How does Paragraph scale to have a sizable revenue with customers around the world? And where do you sit in that supply chain? How do you make that work?
With a lot of hard work, I think, is probably, and some very supportive investors. So it's the challenge of a scaling company. How do you get outside your own ecosystem? I mean, we look at the UK at the moment. Yes, we've got great innovation, but the markets for semiconductors are actually offshore for the main volume of semiconductors. So penetrating those market spaces is key to having a successful company. So really, early on, you've got to think about who your customers are, where you're going to go with your technology. Actually, you've got to take a really strong look. Rachel talked about it earlier about being in Taiwan. You've got to make sure that you have those clear strategies for how you're going to deliver to the areas we're talking about. And there are challenges, right? For example, some of our technologies now can't be sold in China because we're working with nanomaterials, and there's a potential security risk there. So understanding the landscape that you're going to operate in and understanding which landscapes you have to be in is really, really important. Like Richard just commented, we acquired a company last year as well in San Diego. The reason for doing that was to expand our base in the US, but acquiring a company that was in the middle of an area where our technology was going to penetrate. So looking out for those opportunities of where you can find synergist organisations that will offer you that route to market. Because at the end of the day, we can be as innovative as we like with our technologies. As if you don't have a market, what's the point? I think Jamie brought this point up.
I just refer back to Jamie, and you're right. It's people, isn't it?
Yeah.
You meet the people, you think we can work together, then you have a discussion about doing business.
That's another important point. At the end of, at the core of Paragraph is the people we have. And the materials we work in are very, very unknown. And so when we acquired that company in San Diego, there was 15 people there that knew graphene. Nowhere else in the world can you get that. So having them be your advocates and evangelists as well, because they're the world experts, gives you those pathways into market spaces.
Richard, do you want to weigh in on supply chain and scale up?
Sure. I mean, we started with a licensing model, and then I guess we discovered through our innovation that we could actually manufacture in the UK, and that's what we decided to do. We were supported very early on by ARM alongside CIC, so we had sort of patient investors, and one of Jamie's co-founders, John, helped us to develop an approach called design technology co-optimization, which is very much about sort of what it says in the tin. So I think there are opportunities to sort of build manufacturing in the UK. It isn't the only answer, and I think going back to the discussion in the previous panel, pointing to our strengths and being really clear about that. And yes, to be successful, you need to have the product market fit. I think the US is an incredibly important place still to do that, to go and find those customers and to have very sort of open discussions that you can then feed back into developing the right technology and what products that can enable.
Yeah, I think I'm going to make a couple of comments. I want to ask Andrew something, but it's tricky, right? Product market fit, because here you've got an emerging technology, emerging material, and you're obviously going out and there's a range of potential use cases. You've got to go figure out where they are and where the market is. Arguably you're building a market. Quantum computers is another really good example of that. I want to make a comment about government subsidies. Surprisingly, yesterday it hasn't come up yet, so I'm going to bring it up now. So obviously the US has the CHIPS Act and various other, the Inflation Reduction Act, etc., IRA, bizarrely. But the CHIPS Act, the investment in the US for semiconductor itself is $50 billion, right? The EU equivalent is also around $50 billion. What I find more interesting, because obviously they're huge geopolitical blocks, much larger than us. India, however, is investing 15 billion, Spain is investing 13 billion, and Germany is investing 20 billion. They're big numbers, right? I won't refer to the announcement from number 10 last year about our plans. And I just make the comment to put it out there. And what I wanted to, I guess, state is that there appears to be an unlevel playing field globally, right? So, if you're building a facility to manufacture graphene sensors, and then somebody in the US sets up as a competitor against you, they're probably going to be receiving some money you're not going to be receiving. Let's not go into that right now. I want to turn to Andrew, but I'll just put that out there. What would you say about, I'll ask the glib question, what's the key emerging material? Right? It's not that simple, is it?
Yeah.
Right?
So actually, I think that comes back to an important point that touched on a few things from earlier. From an academic perspective, it's easy to think that stuff gets sold. And the thing I've learned is that stuff gets bought. And unless you have something which people want to buy, you haven't got a market. And that's, I think, one of the real challenges with emerging technology, that actually as academics, we're pushing the boundaries of materials and we're coming up with ideas, but actually we're not the people who are close to customers. And I'm going to push back a little bit on a comment that Jamie made, actually, about what the expectation of academics is. That actually, I don't think you can make all academics jump through an innovation hoop And actually, some academics are really good at just focusing on a material and sort of thinking, what does that mean? And it's about coming up with a combination of people, including people who can see that vision through to a market and customers, and pairing them up with the academics who are really focused on the sort of the paper generation, and building that team of people who can then translate technology through to an endpoint. And one of the challenges then, I think, for a company growing Sorex, so we've sort of started off from a very sort of fundamental academic EPSRC funded project. We came up with an IP and an idea that was really quite theoretical. And it's been quite a long journey to get where we are. And the thing that I've learned from that is that we're making sort of MEMS-based sensors. So we could, and we do, get them fabricated in the Far East. We could just be part of a supply chain and sell them to another OEM and make a tiny bit of money on each of our sensors in the process. Or we could get closer to a customer, a real customer at the end. And this is why I sort of talked about the agri-tech business at the start. Because as Rich said, with things like healthcare and agri-tech, there's so many emerging opportunities in terms of actually changing the way we live our everyday lives. So in agri-tech, if we can be more efficient about how, for example, we use pesticides, because we can do detection of when sort of pests are starting to emerge in a crop, or when animals are starting to get sick, so you're doing that early intervention, kind of in a different space to the health one, actually, which is another one which I'm also interested when we start to get sick, but it's an easier one to get into. But the beauty there, I found, is actually there are people in the UK who have got these problems, who I can talk to, I can get up close to, and now I can think about getting a product that goes into their hands and actually then get the full benefit of maximising the value of the IP that we've got by selling it all the way to an end user. Now, the challenge I'm going to face is at some point I'm going to have to do back-end of line processing and packaging here in the UK, and there's a problem here of there just not being the capacity and the infrastructure in the UK that lets me do that. So that at the moment is sort of the bottleneck. That's why I'm going to be needing investment in the next sort of year or so to enable me to do that. But that then gives me the real value add. And coming back to it, so I've ducked the question by saying, actually, it's not about the material, it's about what customers want, and having a smorgasbord of academic basic research that then means that when those magic moments occur, that there's an emerging opportunity and an emerging material, we can take advantage in the UK, and we've got the supply chain to do it.
If I can jump in on that, I think that highlights, I think, it's about how you enable a supply chain for different scale and different stages. So one of the challenges in advanced packaging is it's really difficult to engage with the big players there because they're looking for $20, $30 million worth of business that you can take to them. And if you're at that early stage, there's a market failure essentially, and that's where I think government could invest. And actually, the UK is sufficiently small and there's sufficiently sort of common number of requirements that's where government could invest and intervene to say, okay, this is how we cross the chasm for companies that want to move their advanced materials or advanced sort of emerging technologies from early stage through into later stage. And then there's already existing supply chains, some of which is in Europe, some of which is in Asia, and you can scale from that.
Actually, you see that in China, managed economy, but you also see it in the US as well. There'll be an initiative for a particular area, for example, it could be new materials, high efficiency electric drivetrain, right? And that would end up being silicon carbide or gallium nitride or whatever. And, in China, the government will get behind it, put a fund of money up and basically make companies do this. In America, they do it in a different way, but they achieve the same result, to curate that middle tier supply chain so you have a jumping off point to go to the rest of the world now.
Maybe I can come in because I'm curious because it was mentioned in the previous panel about politicians with hard hats and things, and I think it's interesting because within the supply chains, particularly in the UK, we've got to recognise that different facilities are needed at different points, And I think it's worth recognising that the UK does have a bit of a gulf, beyond the academic first proof of principle, maybe not quite into large-scale fabrication, and right in the middle where you're trying to scale up production. You pretty much need decent quality fabrication, but you're not at the scale. And I think it's useful to highlight, it's incredibly impressive to hear of companies setting up their own fabs. We did not choose to do that, but it is a massive risk. And I think for politicians expecting to wear their hard hats, it should definitely not be the case that they expect earlier stage or even late stage companies to build their own facilities because they're taking on that risk. And by the way, that can very easily lead to challenges in terms of things like that. So you look at other countries and there is this middle ground which is filled pretty effectively with sort of national centres, but definitely not universities, which are there to facilitate scaling up and high quality production, maybe more focused towards. And I think whether or not the UK can own that space, bearing in mind we've got to focus or not, but it is definitely a gap that we have when you're trying to bring an earlier stage concept and emerging technology in semiconductors to market.
Yeah. Okay, we have just about 5 minutes left, so I'm going to open it up to the floor and see if we've got any questions. Oh, there's a hand up straight away over there. There's a mic coming, I think. Oh, go and shout.
I'm new to the sector. It's been a fantastic day learning about semiconductors. I'm just interested in what Richard was saying right now about this gap in the market. And what does this infrastructure look like? Can you just describe it to me? How big is this manufacturing place that you have in mind? Is it something that is linked to universities? Is it commercial oriented that requires a lot of space around it? What does it look like?
That is a great question that I'll give an answer to, and I'm sure everyone else will want to wade in. What we see in the US and in other places is, let me just comment. In the UK, you have lots of university-style fabs, and the thing that everyone mentions is the problem with each machine is it's all accessed by PhD students who are still learning and will mess up a lot of stuff and break processes very quickly. So I think what we observe is the sort of thing that's missing is, often it is linked to university, but it's very much distinct from universities and probably distinct from teaching. It's a commercial facility, and it's funded to the extent that you have things like redundant equipment. So if one piece of equipment goes wrong, then it's definitely set up to facilitate companies. Often it's filled with company employees, shared use facilities and things like this. But it is separate from, there's maybe a little separate from universities and university thinking, maybe university funding, in order to be built as a very specific focus, in one. And this is an active area of discussion, I guess. But there is a model which is successful elsewhere, which I think the UK hasn't quite gotten up to speed on yet.
Richard?
Well, I guess over the past 13 years, we've actually navigated that model. So
yeah.
we started in Andrew's lab on the West Campus, and then we worked with institutes I just described in Europe. There was a facility in the northeast of England where we could go and start to use facilities there and use that on an open access basis, and then that allowed us to have our own people, and then we could put our own equipment into that. So there's a model that can work. It's essentially requires, but they need to reinvent themselves so that they are relevant at the time and they're able to support sufficient large number of users. So it's not just for one or two companies. And you need the right kind of capabilities and infrastructure and people that can support that. But there's a model in Germany that works called Fraunhofer, and the catapults in the UK that Andy knows very well is an attempt to replicate some of that, and it's been largely successful across a number of areas, and we've certainly trodden that path, but it's not necessarily set up to service everything, and it does need to be reinvented every so often.
I think there's also a difference between pilot and prototype. And I think universities can do prototyping, and you need good facilities to do that. But it's different having a process which you can just scale. And when you're a growing company, what you want is suddenly the big order comes in, and you need 10 to 100 times bigger volume production than what you've currently got. And there you need to already have that pilot line process that you can easily scale to something else. And that is very specific. So coming back to the question, it's not one thing, it's lots of different things, and that's why we can't do everything. You have to pick particular things that you're going to say, actually, we're going to invest it in that, and we're going to enable pilot line production in that area and not in that one?
I want to squeeze another question, but quickly, Simon.
Just very quickly. So I'm just going to round up what you've all said. I'm doing that now. I had to build my own R&D centre. I'm now having to build my own manufacturing facility for the overlap, to get rid of that overlap between R&D and going from prototype to piloting. We have a lot of ex-PhD students on site messing with equipment on our R&D site, which means we have to have a manufacturing site. For new materials, that facility doesn't exist in the UK. You have to do it yourself, which is very capital intensive.
Which, by the way, on the other hand, doesn't exist particularly anywhere, right? So we have an opportunity to level up the playing field, if you like. Right, can we take another question? Ooh, I think the man with the glasses just there was first.
My name is T. I'm from the National Physical Board Group, and you talked about infrastructure and gaps in the infrastructure. And the key part of scaling up from a university lab where you're probably using a probe station to measure something is test and evaluation, so and quality control. So do you see any gaps in the test evaluation and quality control landscape once you get your wafers back from your international partners and clean rooms in Austin or somewhere else?
Simon?
Absolutely. I think we have some great facilities in the UK, research facilities, MPL being one of them, right? But I don't think it keeps pace with what we're doing in innovation. In Paragraph, we've had to invent our own testing capabilities. We work with the MPL, it just doesn't move fast enough. I think I can see you smiling there. Yeah, absolutely. But yes, there is a lack of testing capacity, particularly the cutting edge stuff as well, and a lack of ability to move quickly, because business needs to move quickly. You've got to step out of that academic thought path of how do we invent a new way of making. No, we want to know our product is good, and we want to know it's good today. Not are we going to develop something for 3 years, because we are developing a tool with the MPL, a specific tool that's now 2.5 years into its development. But we've now invented something different on site of our own because we needed to.
So we've only got 1 minute left. The clock is running down. So I'm going to go around the panel and ask you to say a few summary words very quickly. And I'm going to leave you with this thought. Where are the emerging technologies taking us to in enabling? And what do we want to be when we grow up as a country? What do we need to be winners in these new emerging areas? We'll go in reverse. Simon first.
One of the oldest countries in the world needs to grow up. That's good. I think the level of technology we have in the UK is absolutely astonishing, and it comes back to the point that was raised before. Pick what we want to do. Really get behind what we're going to do. And then all the other businesses that are not included in that know what they have to do elsewhere. And that's straightforward.
Okay, Richard.
I think we've got a tremendous opportunity. We are world leading in our science base, and we're world leading in advanced materials, and some of those advanced materials are going to be key to the future of semiconductor and emerging technologies in the next few decades. We're not going to scale all those up here, but we can definitely leverage those, and we can retain a lot of the knowledge and the value here.
Richard?
Yeah, so the future of photonics, in my view, is integrated semiconductor, but it's definitely not the case that all integrated photonics are silicon. In terms of the UK, to be honest, my hope is that the UK is global, sees this as our part in a global landscape.
Okay, Andrew, finally.
And I think there's as people have said, there's an amazing opportunity in the UK. There's no shortage of innovation coming through. And if we can open the taps in a sensible way in terms of investment, I think we shouldn't have any glass ceilings. If you look at sort of Taiwan, for example, a much smaller economy than the UK, and over a period of decades, they have built a world-leading semiconductor industry. And it's not going to happen here overnight in the UK, but we shouldn't imagine that we could not get there over a period of 30 to 40 years.
I'm just going to say one word: ambition and long-term vision. Thank you.
Thank you. So thank you, Charles. Thank you, panelists. That was actually very optimistic, and I'm really encouraged by the boldness of, particularly something I've not seen for a long time, the enthusiasm behind bringing manufacturing back. So well done for that. So now you've earned a well-deserved break. We're roughly sticking on time. So if we can have a break in the foyer, grab some tea, coffee, continue the discussion, but let's try and get back for 12:05, please. Thank you. Okay, hello, everyone. Welcome back. Clearly some good networking and discussions going on. But thank you for listening to the bell ringing eventually and returning. So we now have our third panel. The third panel is all about scale-ups. So I'd like to hand over to Sean Redman, who'll take us through this panel, and you'll introduce the rest of the panelists. So over to you, Sean.
Thank you very much. So that's an honour to be here at Pembroke College. The second Earl of Pembroke was known as Strongbow, and this panel is all about how we put the wood behind the arrow for scaling up semiconductor startups and semiconductor scale-ups. So I'd like to bring up our esteemed panel. The four members of the panel like to come up on stage. We've got Russell, Natalie, and Phil. So we're going to kick off with a first question to our esteemed panel. But before we do that, let's get some introductions. So I'm Sean Redmond. I'm the managing partner of Silicon Catalyst. We run the Chip Start UK program for the UK government. DCIT funded us to reach deep into the university research base of semiconductor opportunities and help take those ideas into scalable global semiconductor companies. We, with the first cohort of 11 companies, took them through 9 months of incubation. We wrapped the Silicon Catalyst ecosystem around them, and that's an ecosystem that was created in 2015 to provide in-kind support, so big friends in the industry, to give them access to design tools, design IP, access to foundry, commercial, legal support. We've got wonderful partners that help us do that. Companies like Goodwin's, I know in the audience today, so legal advice. We have IP lawyer advice. We've got design automation partners with Synopsys, Cadence, and Siemens EDA. And of course, our big partner, ARM, providing design IP support for the needs of designing those chips. But we've also got what makes the biggest difference, and that's the advice. So we've got 350 global executive advisors. They've built mutual respect and trust up and down the global supply chain. So they probably have made many of the mistakes that we want to avoid these startups making, and we project and help and disseminate that advice. And we have a mentor assigned to each one of the startups. The first cohort has raised now, in total, £12 million of venture and angel funding after the 9 months of incubation. We're off and running with the second cohort already, and our single objective is to get that seed funding round. They're early stage semiconductor startups, they haven't raised yet predominantly, and we take them through the process of being investor ready, but we also train them on the semiconductor industry. So we give them 3 deep dive semiconductor industry specific training courses per month. We workshop that to their specific needs. And after 9 months, we release them onto the world stage of semiconductors. So we want to create the next generation of unicorns for the UK. The UK has had 16 semiconductor unicorns, believe it or not. Many of them come from Cambridge, of course. But we want to see that happening across the base of the UK. So that's me. I'll hand over to Russell to introduce himself first.
Thanks. So I think I'm sitting here with 3 different perspectives because the name badge says Viper Core. That's my current startup. We've got that funded beginning of last year. That is not yet on an investment journey for scale-ups because we're still at an earlier stage, but we will be scaling up in due course. We're one of the largest UK-based seed-funded chip startups for quite a few years, probably for a decade. I've got another perspective, which is I help Sean deliver the Chip Stop program, and the reason I do that is because, go back a little bit of time, beginning of the century, I was an early stage hard tech venture capital investor in the days when actually there was quite a lot of that about. So we've got that perspective then we bring that perspective to the Chip Start program, but it's also a question of how we can encourage the VC industry to do more of this, in which case I'll hand over to Owen.
Seamlessly. Yeah, hi everyone. So I'm Owen. I'm an investor at Octopus Ventures. I'm part of the deep tech team So actually focus quite a lot on hard tech, as Russ alluded to, particularly semiconductors, materials, robotics, all that sort of good stuff. I've been in deep tech venture for about 6 or 7 years now, and perhaps a little bit unusually, and we might come back to this, I came through the university sector into venture. So I spent a number of years at Oxford, don't boo, doing sort of spin-out activities with them, helping companies get out of the university, helping secure IP and get them funded on the way. And I have a technical background in materials chemistry, so I very much approach the world of venture through a very sort of technical lens, technical mindset. I currently sit on the board of 3 different semiconductor businesses, including Vipercore. So I have a sort of ringside seat to a lot of this activity. Natalie.
Yeah, thank you, Owen. Good afternoon, everybody. My name is Nathalie Haller, and I'm a director at UK Infrastructure Bank. That has been mentioned in the other panel. Thank you. I look at the supply chain sector within UKIB, and under the supply chain sector, we're looking at semiconductor. I have to say I'm probably a little bit of an intruder within this panel in terms of where we sit in the life of the startup, because we're really beyond the venture capital stage and really looking at the scale-up stage. I guess probably helpful to give a little bit a couple of words on who is UKIB and what we're doing for the semiconductor. So in terms of UK Infrastructure Bank, we are a government-owned policy bank. We were set up 3 years ago. And we're really there to deliver and amplify the government policy with 2 strategic objectives. First one is to tackle climate change and enable net zero by 2050 in the UK. And the second one is also regional, local and economic growth. For that, we've got 22 billion of capital, and it's not the 22 billion that are missing. It's another pocket. And out of this 22 billion, we've got 4 billion, which is for local authority, and 18 billion, which is to be deployed in the private sector. And we're playing across the capital stack, so we can do guarantee, debt, and equity. We've got 10 billion envelope for guarantee and 8 billion for debt and equity. You may have also heard about the National Wealth Fund, and we've been entrusted with an additional 7.3 billion. And we're at the moment discussing with the government and working closely with them in terms of what would be the mandate to deploy those funds. What we are really focusing on is solving issues, and we're really there to complement the private sector. We're not there to compete with the private sector. We are really looking in all of the sectors that we're covering, what are the issues, and trying to help de-risk the investment, and basically, I guess, sometimes focus on the unloved corner of some of the industries. The core sectors that we're looking at clean energy, digital, transport, waste, and water. And on top of those, we've also been receiving steer from HMT, which is our sole shareholders, to look at natural capital, critical mineral supply chain, and also specifically semiconductor manufacturing. Just to give a little bit of a picture of what we've done so far in the last 3 years, we've deployed 3.8 billion. We've closed 38 transactions, so that's almost one transaction per month. And we've also supported the creation of 10,600 jobs. So in terms of semiconductor, which is what is really interesting us today, we are really looking at it under the lens of net zero, given semiconductor as really the heartbeat of net zero technology and also very core to the EV supply chain. And our flagship investment, which was already mentioned in previous panel, is our co-lead in the Series D of Pragmatic, where we supported with 60 million in terms of expanding the manufacturing capacity. We're really looking to provide long-term patient capital, which is really needed for the industry, and also focusing on the scale-up stage. So really looking to give a preferred equity, probably sweet spot, Series C and D, and maybe 5 core criteria to keep in mind in terms of what we can do. First, we're investing on commercial terms. We're not giving grants. Second, we're really only investing in the UK and really focusing in terms of having our use of proceeds for CapEx. And third, we're really focusing on the semiconductor manufacturing, because that's where we see there's really a gap, given it's really CapEx intensive. And that's really, at the moment, where we're trying to support. Fourth, our minimum ticket is 25 million and we cannot take a majority share. And we also usually like to go with co-leads in our investment because we're looking at so many sectors. I think we can say we're not extremely expert in each of those sectors, so we also like the comfort of another co-lead. So all of these give a picture that we're really looking at the growth and scale-up stage, because if you look at this 25 million minimum ticket, the fact that we cannot be majority shareholders, it's really companies that have achieved a valuation at least of 50 million. So it's companies that really have like a core technology and a product ready to go to market with some kind of proof of market adoption and also a TRL of 7 and above. So I will stop there. Hopefully it was helpful to have a picture of what we do. Thank you.
Hi, I'm Phil O'Donovan. I am an engineer. I spent too long at university. I worked for large companies and small companies, and predominantly in the telecommunications and communications area. I joined a great company, Cambridge Consultants, here in Cambridge, a design and development company, and from that we spun out 9 founders, spun out Cambridge Silicon Radio, and that became CSR PLC when we floated on the London Stock Exchange some 4 years later. We started in 2000, early 2000, and we raised $85 million in 4 rounds as a private company, and then we floated on the London Stock Exchange in 2004, and grew to, until 2015, 2,000 staff in 20 offices around the world. And we were a fabless semiconductor company. And our first product was a Bluetooth chip, Blue Core 01. And over the years from 2000 to 2015, we shipped 4 billion of those chips to a large number of customers around the world. Very few in the UK, just I think it was something like 0.5%, mostly to companies in the Far East, even American companies in the Far East who did their manufacturing there. And we started as a fabless company with ST Microelectronics in France, and then TSMC in Taiwan because we needed the volume. And I'm giving the next chapter in Semiconductors speech, a talk, just after this panel. And what I will try and address is that relationship between the very important things in the UK and everywhere, education, and also industry, and how the semiconductor set of businesses does feed into industry, and hopefully still based in the UK, then pays their taxes and helps to fund everything else that runs in the UK. So that's me.
Thank you. Now we've got such an esteemed panel here. We're going to go into questions. And in less than a decade, we've come a long way in this industry. There was a very cold wind blowing that would chill the bones back around 2015, where the industry expert had called us out as a maturing industry with dwindling exits, not particularly interesting for the investors. And the startup dream almost died. So the opportunities to get funding was as dry as a bottle of Chablis, really. And we've come to where we are now, where all of a sudden, everybody's talking about semiconductors. It's great to go to a party and people ask you, what do you do? 10 years ago, you wouldn't even mention the word semiconductors or chips. Whereas now, we are the 3rd most profitable industry in the world. We, as I mentioned before, 16 of the top tech companies, you can call them chip companies, right? All the hyperscalers are chip companies now. They're vertically integrated. They own their own chip design, and they actually make the foundries jump. When Apple wants something, TSMC jumps. That's why we had a supply chain crunch in COVID. They wanted everything, and they demanded it, and they got it. So my question to the panel is, given that's the context of the semiconductor industry, why do we only have a handful of venture capital investors, in terms of companies of investors, in the UK? And so first I'll put this to Russell. Now Russell's raised the largest seed round for a semiconductor startup in the UK recently. So I'm sure everybody would like to know what the secret sauce was in doing that. And that's so my first question to you, Russell.
Okay, well, I think I can really probably speak to half the secret sauce. I probably ought to if he wants to, let Owen describe the other half, because it was his decision, not mine. Owen's one of 5 of our investors. We raised £4 million, which doesn't sound like a lot for a chip startup. There's a whole range of chip startups. Some can make £4 million go an awfully long way, but if you're designing a state-of-the-art server-class processor core, which is what we need to do, that's just the first step. And we've got a heck of a journey ahead of us as we go into scale up. I think we were memorably described by one of our other investors on the day we closed that we were £4 million, 1 engineer and no patents, which I think probably is a fair reflection, well, totally a fair reflection of what we were on the day, and I think it really portrays the sort of, we were slightly out there in terms of raising that amount of money for what was a very early starting point. I think what worked for us was the credibility of the proposition across the board. I've been around. I think one of the things I had on my pitch deck was that I'd been active through not one but 2 global downturns. I was in the industry in the 2000 dot-com bubble bursting, and I was in the industry in the 2008 GFC issues. So we had some experience around the team. We weren't just a bunch of young Turks having a bit of fun. But I think also the quality and the pedigree, the history behind the technology set us apart as well. So I like to think those are the 2 things that work for us. I see a lot of other teams with similar strengths and they struggle. So I think we also benefited from being in the right space. We're doing processor architecture at a time when that's becoming quite an interesting proposition outside of just doing GPUs. So I think that probably had an aspect to it. And we're doing, our technology is being deployed onto RISC-V, which also has a lot of relevance and interest. So I think we ticked a lot of boxes, is one way of looking at it. Do you want to answer the other part as well about why so few VCs, or do you want to?
Let's move on from there, Russell, to Owen, where Owen comes in on this. So when we brought Silicon Catalyst to the UK in 2021, in my wisdom, I thought, right, we're going to do an event. Where should we do that event? We'll do it in an inspirational place. We'll do it at Bletchley Park, where real things happen. Mother Invention solved all of the world's problems overnight, and there were really small teams that did that. So I said, right, let's bring the industry, academia, and government together and talk about semiconductors, because it's a painful problem. The supply chain crunch has been there. Everybody wants to know how to solve it. Let's start the discussion. We brought Silicon Catalyst. So I reached out when I was thinking about, can we bring investors to that discussion? Now, Owen was one of the few. I think there was only 3 VCs at that time, with probably 20% of their fund allocated to looking for deal flow in semiconductors. I was pretty shocked myself, having spent nearly 40 years in the semiconductor industry, having run Cadence in Europe, and we used to do investor events, so I didn't realize how bad it had got. But we're in a much better position now, but we're still not there. Owen, why are we not there yet?
Yeah, it's an interesting question. And I think it is absolutely right what Russell was alluding to, that there are a lot of good companies out there at the sort of seed and Series A stage that go unfunded. And so it's not a quality of deal flow problem. There's plenty of interesting deals out there for investors to look at and pick up on. I think there's an element that venture capital in a way has sort of forgotten where it came from, which is the original sort of VC investors in Silicon Valley. There's a reason why it's called Silicon Valley. There's a reason why some of these big deals were so successful, was that VCs were taking a bet on companies that had huge amounts of technical risk, but ultimately very, very little market adoption risk. They were developing something that was so meaningful, so powerful, so paradigm shifting, that obviously someone would want to buy it, and there was all kinds of bits of evidence that you could look at to persuade that. I mean, companies like Intel, for example. But that seems to have sort of fallen away a bit now. VCs aren't looking for that anymore. I think they've got a bit too used to being able to invest in sort of B2B SaaS companies where there is very minimal technical risk, and you will wait until there's revenue so you can say there's very minimal market risk, but actually there isn't the same level of upside. And I think there's a tendency from VCs to focus on trying to generate a return that's somewhere between 3 to 4 times, rather than taking the big bets and hoping to get 100 times, but also accepting you might expose yourself to a few zeros along the way. I think in the UK that is something that is cultural as much as it is sort of technical and philosophical. And I think actually by having, and I alluded to this at the start, I think by having more VCs getting into the industry who are able to quantify the technical risk they are taking on will allow VCs to take more bets in those areas. So I think in the UK we probably have a lot of people in VC who don't necessarily want to grapple with the technical risk and therefore won't want to take it. I think that needs to change. We can talk about skills and how that relates to that a bit later.
Thanks, Owen. I'm going to reshape this question for Natalie, because as she rightly says, she stands out from the crowd. She's a wonderful government instrument with huge amounts of funds from our Treasury. £3.8 billion, I think, is the number we went through.
That we've deployed so far, and
fantastic. Now, the challenge here is, as that money chases the infrastructure investment of semiconductor manufacturing, where probably the natural VCs will to hold back until they get real proof and mitigation of the risks. And to go from lab to fab is more than a 10-year journey, much more than a 10-year journey in reality. But it's so important now for the UK government. I mean, I'm fascinated by this pushback into an industrial strategy. I was 3 years with Greg Clark every Friday afternoon talking about industrial strategy. We produced a huge pile of paper. It ended up straight in the bin. I was part of that, but we did create Made Smarter Commission, and some great things have happened out of that. Now, I'm much more hopeful for this next push. But fundamentally, the UK Infrastructure Bank is charged with a net zero-based narrative. Semiconductors, in my view, is the only way to solve the net zero problem. Every time I mention that, people look at me like I've gone stark raving mad because they think semiconductors are actually producing the problem. Well, let's look at that. So industrial strategy, we always on the Friday afternoon and ended up talking about productivity. Industrial strategy, productivity. How do you solve, and UK is, because we're in the UK, you talk about it because we flatlined our productivity since the financial crash. No one solved it yet. We couldn't solve it on a Friday afternoon. UK Infrastructure Bank will look at trying to solve that. Now, industrial strategy, productivity is key to industrial strategy. The only way to solve productivity is to deal with energy. The only way to solve the energy crisis is not about creating more energy, in my perspective, it's how we use it. And the only way to solve that is with semiconductor innovation. We had a paragraph on the stage earlier talking about 1,000 times less energy. We all talk about the big CHIPS Act monies, which are all about silicon. We are not all about silicon in the UK when it comes to manufacturing. Forget that. That's a horse that's left the gate. We're about the next generation of technologies which will significantly reduce the amount of electricity consumed. If 30% of AI compute in the cloud is going to be, the consumption of energy is 30% of the world's consumption is AI compute in the cloud, and electric motors is 50% of electricity consumption globally. Semiconductors is the key. So UK Infrastructure Bank should play a role in that, Natalie. What's your view?
Yeah, no, I think I totally agree. I think probably one comment I would flag that you already made is in terms of making the link between net zero and semiconductor, and I guess it's not straightforward, and I think probably also the industry is maybe suffering a little bit from knowledge availability, because I guess everybody knows semiconductors now are in every modern device, but it's true, I mean, it's only been a year that I'm looking at semiconductor, and the first time I was told, like, yes, this is critical for net zero, I was like, semiconductor, I think it's a phone, it's a chip, etc. So I think there's a lot of education to be made in the finance community, probably not the VC stage, but more like the scale-up stage, to kind of understand and make the link towards those two goals. And I guess when we talk net zero, we also talk about electrical vehicle, and obviously semiconductors are all in the automobiles, but it's also extremely critical for this EV battery supply chain. So definitely I think it's one of the most important sector or added sectors that we have in our mandate, where we are going to be there. Plus, obviously, manufacturing means also a lot of creation of jobs, which is also fitting with our second goal, which is regional local economic growth. So I think Indeed, fully agree, semiconductor equal net zero, especially in terms of energy efficiency, but probably some education required, or like the finance community to kind of grasp it a little bit more, because I guess at the moment it's more looking at clean tech technologies, maybe more like the darlings of where you would invest, as opposed to think like actually semiconductor is also another very effective way to support net zero.
Thank you, Natalie. Now, we're honoured to have Phil here. So we love bringing out those that have gone before, right? Those that have done it. And Phil's one of the few that have created a unicorn company, semiconductor company, here in the UK out of Cambridge. So Phil, when it comes to the investment back then, you attracted the right investment. I've heard you say a few times over the years that you wish you'd done it in the US, not here. Was that because of the investment environment there?
Yeah, just on that, our first round in 2000 was with Herman, Amadeus Capital, and with 3i, a British government-backed investment company that doesn't exist anymore. And second round actually was with Intel Capital, because we, as a global company, fabless semiconductor company, serving the Bluetooth market, we were clearly going to be global. And our then we did a corporate round because we wanted to involve people like Arm and Philips and Ericsson. So there were some 15 companies in that round, and we raised, I think, $35 million. And then there was a bank round because we were advised by our bankers as we floated in 2004 that we needed more investment. We said we don't think we do because we had a fair amount of money in the bank. But we needed apparently to meet the third rule of capitalism, and that is if you have no money or little money, you won't get any more. If you have lots of money, then people will give you more money. So they said we needed more money, and we put that in our bank account and we floated, and it was a successful flotation. I think coming to today, one of the messages is perhaps too strong a word, and I'm giving the talk after this panel on the next chapter in semiconductors, is that the fabless semiconductors, being a fabless manufacturing company, is a great thing to do here in the UK. Unfortunately, we don't have a lot of semiconductor manufacturing industry, as has been pointed out earlier, certainly in standard CMOS. So you need to go worldwide for that. You need tier 1, tier 2 companies to help you as a fabless company get there in terms of testing and packaging and all the rest of it. Some are in the UK, certainly, not all. But in terms of raising money and the US, I think increasingly now, I do, depending on the companies that I coach, and after CSR purchase in 2015, I became a Cambridge Angel, some 60 of us, cambridgeangels.com, and really we coach, we look at companies, and then if we like them, we invest in them, generally as a small group within the Cambridge Angels club, because we are very diverse. We're mostly founders of companies who have exited, but we cover healthcare and pharma and all sorts of subjects. But as the companies I coach, and Forefront RF is one of those, a fabulous semiconductor company that will be replacing the filters in mobile phones and doing that in such a way that one can use your phone across the world. At the moment, there are, take the, I don't know about the 16, but the iPhone 15, there are 6 variants of that. And if you have one in China, it'll work there, but it won't work in the UK, except that on 5G, that is, it'll work 4 and 3. But as a fabless semiconductor company, you need vision, you need ambition, was mentioned earlier, because it is a high risk, it is a high reward business if you are successful. Something like less than 1% of fabless semiconductor companies, actually tech companies, are successful, very successful. And more than 50% go bust within 5 years. So you wouldn't do it if you like a quiet and easy and controlled life. But America is certainly still seen as the place where there is capital, and capital that knows where to invest, and actually something that I might touch on later, capital that does seem to respect and admire the companies and their founders in such a way such that the founders, Bill Gates, Mark Zuckerberg and the others, do seem to continue through to whatever their exit, if there is an exit, might be, in the same way that doesn't happen in the UK. That being said, in the early stages of a company's life, for tens of millions of pounds, there are very good companies here in the UK, venture capital companies. But if you're wanting slugs of 20, 30, 40 million, not too long after your foundation, then you certainly need to look abroad.
Thank you, Phil. So I'm going to jump to my fourth question. We want to make sure we have enough time for our audience. So the semiconductor industry is famously categorized by its cost of failure. And if you look at advanced silicon CMOS, the cost of designing an advanced silicon CMOS chip, it's got to the point where it's pretty much making your eyes bleed, certainly north of $500 million to get to your first product. So how do we help UK startups and scale-ups navigate that difficult path and make sure they get to the product market fit they absolutely need for success? Now, Russell's got that challenge right now, so let's hear from him.
So you want to give away my entire thesis the next 4 years? I'll give it a go.
I'm sure Owen wants to know that.
I think one really interesting perspectives, typically panels get together and have a chat a few days or weeks before these things come together, and Phil and I resonated one particular thing, which is one of the things I've been pushing through with the chip start cohort as well, is a lot of the stuff in this sector comes from really clever science, and a lot of the stuff also sometimes as alternatively comes from engineering experience. And as Sean mentioned at the start, we reckon there's about at least 16 unicorns over the last 25, 30 years in the UK semiconductor sector. And if you look at where they've come from, yes, a lot of them come from Cambridge, which is great, but also most of them are engineering-rich companies. Most of them are ones where, yes, there's some science and innovation there, but actually the benefit of having 15, 20, 25 years experience and some grey hair is what's given the insight that now it's possible, it wasn't possible before. And I think we've got to, it's not just the UK, most of Europe has this focus on fostering science and innovation from that research sector, and actually we'd love to try and see a lot more coming out of the engineering sector. I think that would give a lot more experience there, give the confidence to move forward, to answer the question. I think I see that engineering mentality is key. You have a lot of problems to solve as you go through this journey, a lot of problems you expected to solve and even more that you don't expect to solve. And that's the mindset, that experience, which gives you that benefit. So we're looking to hire a very experienced team as we go forward. We've got 17 people, and I think we counted about 300 person years of experience across that team. And we will be, as we grow, we'll be looking to hire grads and skill them up and give them experience, but we'll also be hiring experienced people along the way and keep it going. I think that's vital. I think from the investor side, I think Owen touched on it. If you look at the mentality of the entire VC community today compared to when we had a very vibrant, go back turn of the century, we had about 30 plus VCs regularly investing in early stage hard tech semiconductor startups. When I say early stage, sort of probably spanning what we'd now call seed and Series A, but we've got maybe at best a dozen, maybe in some ways if you count them differently, maybe quite a lot fewer. And a lot VCs that are coming to this space from the more SaaS type investment mindset are really struggle to get the fact that a chip company gets going. There's no sign of a purchase order because customers don't buy off PowerPoint. You need to have a chip to sell something, and in order to sell something, you need funding, and in order to get funding, you need customers. So you're stuck in this loop, which is a nightmare to break out of. So I think there's two ways of fixing that. I think the companies need to be focused on making sure they do have as meaningful a market engagement as they can get as early as possible to give the investors comfort to open their checkbooks. And at the same time, we've got to, the thing that VCs hate is the concept of, go back to the old movie Field of Dreams, build it and they will come. That's actually what most chip startups are trying to do. There's a belief from the founding team that this is interesting. Someone somewhere has got to validate that. and then persuade investors that it's right. Now, that could be from the investors having more domain experience and understanding the dynamic, and that's a really hard thing to do because that's just not how the current VC community is configured. Maybe it's, maybe there's other ways of fixing that as well.
So we'll open up for questions to the audience. Who has a question for the panel? One at the back. Helen, there's a mic just coming to you.
Helen Duncan, Blue Shift Memory. Is it true to say it's more difficult to get investment for a startup where the founders all have an industrial background rather than one that's spun out of a university? And also in a similar vein, I'd like to ask Phil, because both CSR and ARM spun out of an existing company rather than out of a university, do you feel that in today's environment you would actually get funding now from investors as well as support from your previous company?
I think the answer is yes. Certainly as an investor now, looking around, there is no shortage of good opportunities. There were 9 founders of CSR. The 3 founding directors, James Collier, Glenn Collinson and me, all had some industrial experience. We'd worked for companies for a reasonable number of years each. The 6 others who were engineers had some experience between them, but some were very young and just out of university and only at Cambridge Consultants for a short amount of time. But I think the key thing that's important is not necessarily one or the other, academic or industrial. It's what you're offering. And I certainly know now as a Cambridge Angel, there are some, pretty much for all of us, some 7 or so things that you look for in a startup team. And it's, it's ambition, it's vision, do they understand the technology, if that's what you're needing to implement your idea. But is there a product market fit, which was mentioned earlier? And then how can you, and hopefully you recognize the gaps in your management team, your set of founders, and how to fill them. And I think if you can do that, and if you're working in an attractive area, and certainly for Bluetooth, for filters, for mobile phones, that is an attractive area. 5G, is going into watches, it's going into IoT products, going into all sorts of things. So industrial experience per se is not something you must have. If there's a spin out for a university, and there are many of those, and the people have, the core skills necessary, but know that they need somebody with perhaps some making experience and some selling and marketing experience, and they, agree that those people need to be recruited when the money is raised, then that's all you need.
One comment on that, actually. I think some of it is also to do with the balance of where the money is at for venture capital at the moment. And what we've seen over the last few years, some of the biggest funds that have been raised in the UK have been, well, for deep tech, have been aligned directly with universities or particular ecosystems. So you only have to look at Oxford Science Enterprise, Northern Gritstone, Cambridge Innovation Capital. Like these are very big funds, but they're all constrained to certain areas of deal flow. We're one of the few funds in the UK that has the ability to write 5 to 10 million checks into deep tech companies that is completely sort of region agnostic. And so I think that's why it may seem that more spin-outs are getting funded than industrial sort of teams, just because there's not the money there, which gets back to our previous point.
Thank you, Owen. So we've come to the end of our time. I'd just like to conclude by asking the panel to comment. Now, I believe there's never been a more exciting time to be in the semiconductor industry. It really, I get up in the morning and think, wow, what's going to happen today? What's happening next? And so, just one sentence from each of the panel members, starting with Phil. Why do you think it's so exciting now to be in the semiconductor industry?
It's exciting because semiconductors are the enabling thing and also the glue within products, and we will continue, whatever we do, to use products. And it has been said also, it will minimize, for example, energy uses usage in products we're already using. So it's very exciting, and the fact that we have a good number of universities doing research work, corporations who do research work, not so many these days, but it is that glue and it's not going to go away.
Natalie?
Yeah, and I would say semiconductors are foundational for modern life. I think right now it's really in front of the news. Every day you read about semiconductor. It's also in the crosshair of like geopolitical tension. So it's really like an exciting time to be there and try to have make the most of it for the UK.
Thanks. Owen?
I think it's just one of the few technology areas that could genuinely change the world for the better, and make lots of money along the way, which I probably should say. Yeah, well,
I think it has the potential to change the world. Someone said in the previous panel how much difference we've got over the last 50 years. There's that. There's from the engineering perspective, it's one of the most exciting, intellectually stimulating and satisfying tasks. Being all the engineering disciplines, chip design and semiconductor engineering is, it's one of the most complex and fun to do. When we had complete drought of chip startups getting funded around late 2000s after the GFC, one of the questions the industry asked itself was, maybe that was it. Maybe we've invented everything there is to be invented. I think we can now say absolutely not. There's so much more to do.
Splendid. Thank you, everybody. And thank you to the panel. It's been a fascinating discussion.
Thank you, Sean. Well done. Good job. So very, very intelligently, Phil has already given some trailer for our next presentation. So he seeded the room with some of the ideas and maybe some of the questions he's going to answer. So for our final presentation, please give a round of applause for Phil. Thank you, Phil.
So, the next chapter in semiconductors, and if that's the title, or if that's the book, then the subsection headings. Sorry, it's not the title of the book; it's the chapter title. I couldn't work out what the title of the book ought to be, so I didn't put it up there. But these are the headings within the that chapter. Semiconductor research, of course. Facilities helping to exploit the research, that is, getting research from the universities into some corporate organization that will perhaps make money for the founders, for the investors, and the staff, of course, and indeed the country in terms of paying taxes. I remember an MP visiting Cambridge once and meeting us, and he said, "We really love you." And I thought, okay, what's this about? He said, "You pay so much tax that we appreciate you being here in Cambridge and paying that tax." And until we were purchased, of course, our HQ was in Cambridge. We were a British company and we paid a lot of tax. C, semiconductor industry ecosystems. I'll say a little about that later on, from startups through to segment leaders and companies that float, like we did on the British Stock Exchange, and hopefully then remain companies rather than being acquired by others. But of course, it's great to float on the stock exchange. It's a source of capital. And I remember one of our first companies, our first customers, Nokia, said, "We're wondering when you're going to float, because you're the only supplier that we have who supplies this amount of goods and is still a private company." So that made us think about floating. But then we were bought by an American company later on. I'll come back to that. And then the UK semiconductor policy, which is, of course, very much a topical point at the moment, given the change of government. So, I'm pressing the button here. There it is. And a little diagram here. Semiconductor research. This is a model, really. The things I've already said, A, B, C, D, E, and D, in terms of the subsection headings. Semiconductors at the top, an awful lot of intellectual property and know-how generated, goes through to C, the ecosystem, which is used by companies that actually do things. They might make products like CSR, sell 4 billion chips, or they might license their intellectual property to others who make a lot of chips, like ARM, of course. And then for those UK companies that are based here, those taxes go back up, help to fund universities, university work. So it's a self-fulfilling ecosystem, a virtual circle, in fact. But that model on the right-hand side, growing successful companies from startups going in the funnel, like a sales funnel, and coming out at the bottom, less than 1%, as I said earlier, very, very successful. If you Google studies on success, you will actually see those numbers. They range from about 0.25% to about 2%. Okay, semiconductor research in the UK. I don't have enough time to say a lot about that, but you can read the bullet points there, and a lot of you know about that research. We do super research here, from bulk materials, surface materials, through to photonic structures, and indeed quantum, things that are known as deep tech. And I'll just make that comment about deep tech, and that we might have a discussion about that. I don't think being a fabless semiconductor company is deep tech. You have to have the right idea, you have to have the product market fit, you need to engineer and produce a winning product, and you need a lot of staff with skill, experience to do that, and you need a big pot of money to do it. But the way of doing it is actually pretty known. It's been done many times before, the fabless semiconductor model, that is. And there's no reason, if you follow the rules, why you shouldn't be a success. But I'll come to that a little later. And as has been mentioned earlier, actually Cambridge and San Jose are the two most intensive ecosystems, science and tech ecosystems in the world, according to a study, which I provided a reference for there. And you measure that intensity by the sum of the patents of the scientific publications divided by the population within that city. And that's, we're right up there at the top. And what is it? How many patents, global, how many Nobel Prizes coming out of this area? I think it's about sort of 161 over the years. It's a large number. So that research, that IP-intensive work, drives the creation of world-leading companies. So just as an investor, we often see a pitch and we think that's a great idea, but we say to ourselves, this is a science project. We can't invest in it because we don't know how long it will take to come good and how much money it will take. And there are many science projects around, and certainly as an investor, as a Cambridge Angel, it's necessary to look at how feasible it is to make money as an investor there. And fabless semiconductors, that model is a good one to follow. So, next slide. I'm pressing the button here. Do I need to point this anywhere? There it is. Fabless semiconductor model. I won't dwell on that. But the great thing about that model is that as long as you've got the design right, and as long as you can deal with the fab, you get the chip out at the other end, and you then drop ship it from that other end to your customers all over the world. Very few, if you're a British company, very few of whom will be in the UK. But I think the important thing there, and it's been said earlier, scale of the fab. If you're dealing with standard bulk CMOS, and we put RF into bulk CMOS at 2.4 gigahertz, which is the frequency at which Bluetooth operates. And that was a first at the time. And by the way, one of the reasons that we could do that is that James Collier, the CTO, co-founder of CSR, was actually using 2.4 gigahertz for some work that he was doing with Ericsson at the time, who was one of our customers, contracted to do work. And we made some chips for Ericsson, and it needed 2.4 gigahertz. And the very large semiconductor players at the time hadn't really thought that this would be coming in the next couple of years. They thought it would be more like 5 and 6 and 7. So when Bluetooth was announced in 97, 98, as a standard, it was put together by Nokia, by Ericsson, by Microsoft, and a few others, adding up to 9. We looked at that standard, and actually we saw that at CCL we had been developing intellectual property for a lightweight radio protocol, a proprietary one of our own, which actually was very, very close to Bluetooth. And therefore, we changed a few things, and we called it Bluetooth, and we became special interest group, the SIG, member number 10. Actually, it was 11. And there are now something like 40,000 members of that special interest group, and you need to be a member in order to get all the documents, but also some access to some of the intellectual property that you need in order to implement Bluetooth and put your Bluetooth stamp on the chip after it having been tested by a test house. So what we don't have in the UK, of course, are the large semiconductor fabs that generate the chips. We had to go to ST Microelectronics in France and then TSMC in Taiwan for the volume. But we don't have the factories here that make chips in the way that we used to have in the 80s and indeed the 90s. There were many American and other companies in Scotland and Wales, and they made chips. And the people with the skills concerned with the manufacture of chips, we recruited many of those. And indeed, our VP manufacturing, Chris Laddes, was from a large semiconductor company, and he was a great manufacturing head. But they don't exist in the same way now in this country, unfortunately. Pressing that button. Whoops, did I skip one? I did skip one. There it is. There's just another little diagram that shows us in the middle at the top there, CSR. We designed products. We used TSMC in Taiwan, and going around that circle there, we had a partner program. We only dealt with 15 customers initially, 5 market segments, 3 customers each, 3 times 5 is 15. Everybody else was served by our partner program. And that was a nice picture of King's College there in the middle. So, model semiconductor industry ecosystem, getting the idea at the top, going through startup, then scale up, and you've had some talks on scale up. Very useful to know what you should be doing in terms of growth, but getting the money to grow again is, if you've got the right opportunity, is not too hard. Segment leader and going through to global category leader, which is what we were at CSR in 2015 when we were purchased by Qualcomm. And that's the problem that we have here in the UK. And that is, for whatever the reasons are, our companies, particularly public ones, because of the rules, and the rules are quite right, as a floated company, your stock is available to be purchased by everybody. They buy it, they buy enough, they make an offer for the company. We were purchased for $2.5 billion, $2,500 billion, and that was a good price. The board considered. The board said yes, then came out to the shareholders. I was one of the shareholders. I voted no, because as an entrepreneur, I sort of tend to think that the future is going to be better than the current, and I thought the share price is okay now, but it can be better. And I lost, and we lost. I was one of the 8% that said no to the purchase. The 92% said yes, so the company was bought. And at that time, by the way, the board of CSR, London-based, the board, we were on the London Stock Exchange. The board was rather a large one, some 20 more people. More than half were of a finance background, and more than half were non-UK nationals. There were no founders on the board, and the board at the time thought that the price of the shares had gone up since flotation. It had gone down a little, and then it had started to go up again. And that was the price that was paid, to 2.5 billion. And I thought it could go higher, but the board thought not. But as I say, there were no founders on the board at that stage. So I think one of the things, whatever we do, we could look at is why companies top out here in the UK. Why they don't or are not able to. It is ambition. Well, as I say, the founders weren't on the board, so their ambition or otherwise wasn't actually reflected. But what are the reasons? So, as I say, as a Cambridge Angel now, I mentor a lot of companies, like Jamie mentioned earlier. I give a lot of talks to business schools and universities on entrepreneurial topics, and this is one of the slides I show. Growing successful companies is actually not rocket science. And in fabless semiconductors, it's not deep tech either. What you need to do is to understand what it takes to grow a business. Fabless semiconductors, all the path is known. It's challenging, it's well-trodden, there are lots of pitfalls. You just need to understand what those pitfalls are and then try and not fall through them. I love Jamie's simile of not look at the pothole, try and look around it, and in that way you will find the path. Don't start a company, of course, any company, if you favor certainty. Be advised by successfully exited entrepreneurs. I didn't mention earlier, but the incubators, the accelerators that have proliferated, particularly around Cambridge, but in London, the country generally, are super. You learn a lot. The mentors are for the networking, for the lunches, for the coffee sessions are around those companies, and they will help a great deal. And focus on customer growth rather than your exits. The exit isn't something you should focus on as a startup. What you need to do is to focus on growing a great company, and in that way there will be any number of exits for those who need them. Investors, or some investors, sometimes talk too much about the exit. What they should be concentrating on is growing or helping the team grow a successful company. UK semiconductor policy, you can all read it, it's on the internet. From the top there, we need a coordinated approach. Those things are education, industry, commerce, private and public companies I've addressed. The National Semiconductor Strategy, actually a summary of that right up front has been mentioned earlier. There's a little quote from it. The government's vision for the sector is, over the next 20 years, focusing on our strengths in R&D, design, and IP, and of course compound semiconductors. The only word I don't see in that phrase is industry, growing companies that make stuff and generate profit and indeed pay tax. Press release there, the Independent Institute to steer the UK Semiconductor Innovation, that was only May 2024, so I hope that goes well. If you look at government websites, what you see, of course, on a lot of policy papers is this was set up by the last government. So implication, what are we going to do now? Hopefully it's still good stuff and it will be used, but then a nice little paper that sort of rounds off some of those thought pieces is from the Centre for Business Research here at the University of Cambridge, a great department of the university, selling less of the family silver, better UK innovation and industrial policies for economic growth. Worth a read. Thank you.
Thank you, Phil. Thank you, Phil. So, and also a special thank you for the CSR legacy. So part of the team, I was telling Phil earlier, from CSR is the team that I look after both in Denmark and UK as part of Samsung now. And still many lines of code with CSR written in. so you can see it stood the test of time. Thank you. Right, so that brings us to the conclusion of this morning's session. And we can now break for lunch. Lunch is at the Milstein House and foyer. I have no idea where that is, but I'm sure someone will direct us. And then returning this afternoon for the climate tech session, for those of you joining that. Thank you for your participation. It's been very interesting, and particularly some of the experts and the panels, it's been very insightful hearing from them. So thank you, everyone.
Good afternoon, and welcome to the Cambridge Tech Week and the final session on climate tech. We're going to deep dive in that session. First of all, I would like to start with a thank you. It's so important to start with a thank you. So if you have to leave early, at least we say thank you. So thank you to Cambridge MC2 Management Consulting. We're going to leave that one. To all the sponsors that contributed to that great week. And again, quite a lot of them, so thank you if you're in the room. And also to the special clean tech sponsor, Nordic Niger. Before we start into the climate tech, I would like you to raise your hands if you know the definition of climate tech or clean tech, if you're sure about it. 1, 2. Okay, don't be shy. All right, so I'm going to read it for you. So clarify a few things before we start. Climate tech, technology to mitigate and adapt to climate change. Clean tech, technology that are low carbon, sustainable, and good for renewable, and good for the environment. So they both cross, you can interchange them, and they all focus on different sectors. Energy, mobility, building tech, waste management, and water. And you will also see that they cross over with other tech. I'm Sylvie Russell, COO of Cambridge Clean Tech. We are the leading innovation network focusing on clean tech and therefore climate tech. We enable connections and make sure that opportunities are created within all the ecosystem. Innovators, academics, universities, professional services, and public sectors. So we are the connectors and we are here to help you. The way we do it is through different activities. The first one being creating network opportunities. So if you are in Cambridge, for example, we run the Climate Tech Club. It's a monthly event co-organized with the Barclays Eagle Lab and with Carbon 13. We also run pitch events, and our flagship event is the Clean Tech Venture Day. If you are a company looking for funding, this is an opportunity. If you are an investor, this is also an opportunity for you. And if you are a corporate, we also need you. In terms of projects, we run local, national, but also European or even international projects. These are on demand, and it's to enable to our network and our membership, our members, to be able to have more opportunities. Then we have the ecosystem and immersion programs, and these ones are on demand. You may have heard of the Desafia London. This is a clean tech program that we run this year for clean tech startup for the Spanish government. And that was in partnership with CISL and our sister organization, Oxfordshire Green Tech. That allows us to create a program that is slightly different across London, Oxford, and Cambridge. So you can see all the interactions that we can create through our network. And last, technology scouting for corporates, for our members' corporates. We just run and closed one for Johnson Matthey just recently. But this is not just about that. I mean, I'm delighted to be here today with the Cambridge Tech Week team and I. We put together, I think, what I hope you're going to find very insightful program. You will see quite a lot of different things. We will run it from data, key things, key facts on climate tech, then explore what we need for the climate tech through the ecosystem to thrive, have a panel with Cambridge consultants to be able to see and analyze what are the opportunities, what are the challenges, how we can scale climate tech nowadays. And then in the second half, we will deep dive into two sectors, energy and new materials. And for each one, you will have the opportunity to hear some key facts from experts, followed by 3 pitching companies. And to close the afternoon, we would be delighted to have Professor Emily Schuckberg from Cambridge Zero, and hopefully she would give us, the way to carry on all the work we're doing. So sit back, relax, not too much. I'm going to give you 2 tasks. One is to be able to write on your notepad or your phone 5 key new things that you're going to learn this afternoon. Second one is to meet and connect with 3 people you didn't know before you came here. And I will test you tonight at the drinks party. Thank you. Now I'm delighted to invite Serena from the room to set up the scene.
Thank you, Sylvie. Wow, this is an interesting perspective to present from. I've never presented in a church before. So I'm Serena, I'm from Deal Room, and for the next 15 minutes, I'm going to give you a quick rundown on the rise of European clean tech. In the last decade or 15 years, European tech and European climate tech has truly arrived. The combined ecosystem value of European tech is now over $3 trillion, which is remarkable. To think that even a decade ago that this was possible is pretty crazy. A decade ago, almost the extent of European tech was a selection of startups clustered around a roundabout in East London with a name that people joked about as being Silicon Roundabout. Meanwhile, California has an entire valley. So to reach 3 trillion is pretty remarkable. Not only that, it's snowballing. The flywheel effect is in full flow in Europe, and what I mean by that is there's now a generation or even 2 generations of tech companies that have been produced and scaled in Europe that are now producing their own startups. So if we take, for example, Sweden and Spotify, there are 32 startups that have been founded by people who've gained experience in working at a unicorn at Spotify, people who've got that kind of experience of what it takes to scale a tech company that you can't really learn in any other way. So now we have 2nd and 3rd generation of startups being produced by people who've seen the way to do it. We've got unicorns all over the continent. People have seen what's possible. There's almost a playbook on how to do it. So now there are cities all over the continent as well that are starting to produce these really strong tech ecosystems. Not only that, there are nearly as many new startups being founded and funded in Europe and EMEA as in the US. The US has a very mature ecosystem with lots of big late-stage companies, but the pipeline in Europe is really strong, the strongest it's ever been. So that's a change, and it's a bit of a reset, and it means for the next generation of companies, it's almost a sort of a more level playing field in some senses. Investment interest in Europe has grown more than 4x. So the investment environment and investor appetite in Europe is still very big. This graph is looking at venture capital investment type, but there's a huge proportion of venture capital that comes not just from VC funds, but from other sources as well, things like family offices, private equity that does venture deals, corporates, angel investors, and former entrepreneurs who've exited themselves and become angel entrepreneurs. What we can see is there are far more active investors than there have ever been. And even during 22 and 23, when things cooled off globally compared to 2021, which was sort of the high watermark of venture capital, there might be a slowdown of deals, but there are just as many investors active and actively investing. They're just possibly being a bit more cautious and selective about what they back. Yeah, let's see. What we can see here is Europe is claiming a higher share of early stage venture deals. So 22% of all rounds under $20 million are being raised in Europe and claiming a larger share all the time. Back in 2010, it was massively dominated by the US in terms of global venture deals, but that's becoming a lot more distributed now. So next I'm going to talk about some of the strengths in Europe. We are moving into an age where there's a whole bunch of new frontiers in tech, the age of deep tech. There are going to be some transformative technologies that are shaping the next 50 years that we're right at the beginning of right now. So things like the future of computing, novel AI, synthetic biology, energy, space tech. And a lot of these areas have an impact or a potential use case in climate. At the moment, we see climate as a horizontal because in every industry impacts climate and it impacts every industry. And these technologies can be applied across the entire horizontal. Another strength is that Europe has the highest density of startups in the world. We often think about Europe as being quite disjointed sometimes, but actually there's this huge density of startups and startup ecosystems that really aren't that far from each other. If you think about the amount of time it takes to get from one end of Silicon Valley to the other by train, and then if you took London as a center point, you could get to Paris, Brussels, Eindhoven, Manchester, Bristol, possibly even Edinburgh, just about. And actually all of these places have really rich and deep ecosystems. Some of them are very specialized, but there's massive depth and massive density and a potential to think about them really as one ecosystem rather than as London or as Cambridge or as Amsterdam. So that's a real strength. There's also huge university strength within a few hours, a huge amount of technology on our doorstep, and a lot of collaboration that can be done just by hopping on a train. Europe, as we know, has great technical talent and research leadership, which is going to be really important in playing a leading role in the future of deep tech, whether that's top universities in general, but also the ones that are top for engineering, for computer science, and for highly cited research publications. That's where Europe is a leader. There are also record amounts of dry powder. That means that there's a lot of venture capital that's been raised. European VCs have raised a lot of capital and they're still going to be being deployed. But there's this big funding gap in Europe. Like US funds are raising about 5 times the amount, even though their ecosystem is 2.5 times the size. So Europe is still very reliant on external capital, particularly at those later stage rounds. As you can imagine, Europe is not alone. We are seeing the US and China also shifting more VC capital towards deep tech. And here's where Europe excels. So this is the share funding across the world in different areas and where Europe is claiming a higher proportion. There's climate tech. 25% of climate tech is being raised in Europe, but other areas are quantum computing, health, space tech. Fastest growing category. So we looked at niche innovation areas and we looked at which were the fastest growing through some analysis. And if you look at the ones that are fastest growing here, a lot of them are in climate tech. So carbon tracking and offset, carbon capture and storage, hydrogen, energy storage, EV batteries. So those are some of the fastest growing and therefore most interesting areas to investors within climate tech. And climate tech has been one of the most consistent areas of growth. After 2021, when everything just sort of halved or more than halved in terms of investment, climate tech and AI were the only 2 sectors to buck the trend. That's for a number of reasons. One is that there's a real market for it if you have a successful solution. But these are also much longer term bets. So they tend to be sort of that 10-year bet. And so it doesn't really matter if you're in an up cycle or down cycle when you're making those long-term bets. In addition to venture capital, European climate tech companies also are using diverse funding options where possible, such as project finance and debt. All in, European climate tech startups are on track to raise 50 billion in fresh capital in 2024, which is an all-time high. If we look at investment by industry in Europe, energy is leading the way there with 5.7 billion, which continues a trend that we saw all of last year, where energy was the leading industry by investment for every quarter of 2023. So what are some of our challenges? So I mentioned earlier, access to late-stage funding in Europe is a challenge. Even though there is more investment being raised by VCs, it's just not enough to match demand, especially in climate tech and deep tech, which are more capital intensive, and they require that longer term patient capital. There just isn't the scale of funds in Europe at the moment that can back multiple companies for 100 million plus rounds. There are a number of other challenges on here. They're not necessarily very specific to deep tech or climate tech companies. Things like around talent attraction and retention, regulation is a challenge, and then there's the competitive environment and what that means for them and the amount of capital that they need to raise. There is a lack of capital markets in Europe, but overall the sort of main one, the most obvious and possibly the most potentially fixable, is that access to finance piece. And you can see that here. This is looking at the share of investment by round at different stages. And the new Palo Alto, that's the 4 hours from London thing, and EMEA, they're raising for rounds under 4 million, just over a third of all funding. But as you get to that mega round stage, it's just over 10%, so big drop. As we know, later stage rounds were affected by the down cycle of 22-23. Early stage investment stayed relatively stable, but that late stage investment fell in Europe by 71% from peak. And sort of related to that, one of the challenges that deep tech has is that it's more hardware, it's more atoms than bytes, and that's expensive to cost. It costs more to build, it's more expensive, which means you need bigger rounds. And that means that the late stage capital crunch has a bigger impact for those deep tech startups. And for those same reasons, it's been traditionally harder to finance. There's sort of this gap between dedicated deep tech investors, where they can maybe come in at those earlier stages, and the later stage generalists that can come in, and you just need much longer periods of time. But there's a lot of different actors who can play a role in this, whether it's corporates, governments, universities, tech transfer offices. We have a lot more data about climate tech startups, climate tech investors in our guide here, which you can download from our website. And Deal Room produced a lot of reports and a lot of insights, not just in the climate space, but you might be interested in this report that came out earlier this week on the electrification of Europe. That's it from me. If you have any questions about our data, about climate tech, feel free to come chat to me. I'll be around, or you can drop me an email here. Thank you very much.
Thank you, Serena, and I hope you had a few new things to note on your notepad. Now I would like to welcome my colleague, Sam Goodall, CEO of Cambridge Clean Tech, and we're going to present us the importance of the ecosystem.
Great, thank you, Sylvie. So I think you've already heard a bit about Cambridge Clean Tech. I'm Sam Goodall, I'm Chief Exec. I joined in 2016, so I've been around since, for about 8 years. And organisation, we started about 2011. So yeah, I'm going to do a little bit of kind of storytelling about our journey and how I think that kind of relates to ecosystem building. But first, I'm going to actually do an ecosystem building action. Okay, basically, what I'd like you to do is talk to the person next to you and share one thing with them that you wanted to get from Climate Week or the session that you're attending today. And I just want you to talk for 1 minute. But before you start, because it's a difficult room, when I start to clap, if you could join in the clap, and then everybody will clap, and then we'll all stop, and then it comes back to me. Okay, so just for 1 minute, talk to the person next to you about something you wanted to get from Cambridge Tech Week. Okay, great. So I at least guarantee myself at least a round of applause, so that's me happy. Okay, so I'm here to talk about importance of a strong clean tech ecosystem. Okay, so clusters, ecosystems, and superclusters drive national economic development, improve the wider innovation ecosystems, and create companies and industries of the future. So I think it's pretty established that clusters, ecosystems are very important. I'm not an academic. This is not my kind of expert field. I don't do tons of research into it. But there's a lot, you know, governments invest super heavily in the area. They really want to encourage these innovation ecosystems to develop. So what I want to talk about is our experience as an organization, both being in an ecosystem and sort of building that ecosystem, and hopefully you'll find that relevant today. Okay, just a little bit about definitions. I think Sylvie started already in terms of what is clean tech and climate tech. So what is an innovation ecosystem? Is that a self-evident thing? So a cluster is a kind of a single entity. So for example, life sciences within Cambridge is a cluster. An ecosystem is more like the whole Cambridge technology cluster or Silicon Valley. So it's non-specific. It's not defined by one particular kind of technology or space. And then an innovation supercluster, which is much less common, is also what Serena was kind of talking to in terms of what Europe is beginning to kind of shape itself into. And we're very influenced by the Deal Room Report in terms of the way we're working. Yeah, and for example, they exist global innovation clusters in Canada around AI, digital technology. And the difference there, which I'll also talk about a bit more, is that the difference between an ecosystem and a supercluster is that a supercluster is designed. There's intentionality about how you build it. You have an organization that's there, whereas ecosystems tend to be more organic. They grow up because of the way businesses form and come together. Okay, so that's what is an innovation ecosystem. Okay, what's in an innovation ecosystem? What are the kind of things that kind of make it work, that make it innovation, or kind of make it innovative, as it were? So this is from the MIT kind of REAP model. So that's a regional entrepreneurship and acceleration program. And basically they have identified these 5 key actors. So the entrepreneurs, so risk capital, investment, corporates, government, and universities. Now, those will feature in every innovation ecosystem. There's also a 6th category, which is like other, which can be things like media, for example, also professional services, those kinds of organizations. And they have different emphasis depending on the ecosystem. So, for example, Silicon Valley is heavily dominated by risk capital investment. Obviously, the Cambridge Technology Cluster is by the university. So they can be in different balance, but they will always be in your ecosystem. Okay, so this is kind of talking a bit about the kind of Cambridge clean tech story. So we started in 2011. You've probably seen some of these statistics already this week, which is about the Cambridge Technology Cluster and the amount of outputs it has. So when we started, we started with 60K. This was before I joined. We started with 60K funding. We had 50 to 70 members. So we were a tiny little cluster on this kind of giant, or within this huge kind of massively performing kind of life sciences technology ecosystem. In truth, I think then we probably didn't know one end of an ecosystem from another or one end of a cluster from another. But that's where we started. Okay, then about 5 years later, and this is more or less when I joined, we joined something called the Scale-Up Program. That was an EU program. And the reason I put this little thing down in the corner is that we realized at that point, we started, okay, so we were an entrepreneur. That was our role within that innovation ecosystem. We're the entrepreneurial partner in that process. We'd had support from the university early on. We'd had some corporate support. So we were kind of touching parts of the ecosystem in our first 4 or 5 years. When we joined the EU program, we then touched into the government ecosystem. We got significant funding, and that allowed us to grow and scale and to internationalize. And it also met one of our challenges, which is there wasn't really critical mass in the Cambridge ecosystem in terms of emerging technologies in the way that there is, for example, in life sciences or the broader technology space. Now, our theory of change as an organization is that we find emerging climate technologies and we help them to scale, hence this scale-up program. We also were able to generate what you call like virtual anchors. So there's not really a clean tech anchor in this technology cluster in the same way there's ARM or AstraZeneca for those sectors. So we were able to work with around 80 European corporates from outside the region to give us that anchor function, to give us that pull through in terms of bringing technology into supply chains. Okay, so then, there's not a date, but I think 2017. So we then launched the Clean Tech Venture. Is that right, Sylvie, 2017? In 2017, we launched Clean Tech Venture Day in London. Now, it had been operating around Europe at different places previous to that, but we took it over and it became anchored in London from 2017. So again, in terms of our ecosystem journey, that then linked us into the risk capital piece. So we're now starting to, with entrepreneur, risk capital, government, university, corporate. So we're starting to touch all parts of the ecosystem. Then in 2019, we launched, alongside the District Council in Oxford, Oxfordshire Green Tech, so a sister organisation. So that's us starting to build the ecosystem. We're now not just part of the ecosystem, we're starting to contribute. So we used our model, we're starting to seed other parts of the ecosystem. So you begin to get this kind of reciprocal relationship in terms of our role and our presence within the ecosystem. Okay, a little bit of a kind of jump to the side. So this is the systemic design framework from the Design Council UK. And this talks about how you then kind of, how you create change in a system. So this is really about the idea of how do you create sustainable change, so drive zero emissions through equitable technology and behavior change, reimagine materials, regenerate places. So you need to take this very holistic approach to how you design your work and your activities. And the key thing here is around leadership and storytelling and radical new narratives. So a radical new narrative is when you tell a new story and that makes people change the way they think or feel about a kind of a place or a location or an opportunity. So our big thing then was around, we would try and put together the golden triangle, London, Oxford, Cambridge. The supercluster idea was a thing. We'd come across it in Canada. We felt that that was something that clean tech needed because you need to aggregate the technology in a different way. So that's this leadership and storytelling piece. Okay, so like full of enthusiasm and excitement, in 2020 we launched Clean Tech London and Clean Tech International, exclamation mark. This is my super sad slide. Then COVID hit in 2020 and then closed Clean Tech London and Clean Tech International. So it's a sad slide both stylistically and in terms of what happened. But that was part of our journey. That was something we would do. We were trying to build that ecosystem, but not everything you do works. Okay, so June 2022, roll forward to Deal Room. We came across this report. Actually, it was in 2023 that I first read it. And this new Palo Alto, this radical new narrative about this region, this 4 hours train travel region from London. So we flicked a few switches, made a few lights go on in terms of our thinking about our place in the world and how we could organize ourselves. So in 2023, we founded the Climate Tech Supercluster based on that model, based on that 4 hours train travel from London. And that was with Oxfordshire Green Tech that we'd helped to seed, also an organization in London that we'd met through our kind of developing Clean Tech International and Clean Tech London. So we start to pull together all the strands of our experience. So our experience in the Cambridge cluster, our experience of internationalization, and our experience of, developing also those international relationships across Europe. Okay, so the difference then, just this reminder, so what the Deal Room report I think does amazingly well is it describes an ecosystem. So, but it's an organic thing. That's something that's happened on its own. It records it, it gives it a name. The difference between an ecosystem and a supercluster, and the supercluster is what we're doing, it's what Cambridge Clean Tech does, which is to intentionally create activities that support, that grow, that promote, that really develop this radical new narrative about a place and about the opportunity within it, particularly in relation to clean tech. Now, as I've mentioned, and as was also mentioned by Serena, because clean tech is this kind of horizontal space, it's a much more distributed technology space, so thinking of ways to kind of create that sense of agglomeration whilst also understanding that it is a distributed technology environment is really important. Okay, so this is a really long slide that you're not meant to read, but this is the importance of a strong ecosystem to Cambridge Clean Tech and the Climate Tech Supercluster. And basically, I could have written this kind of twice over. So there's no part of our work that hasn't been impacted or affected by the by being part of the ecosystem. And I think just to kind of, to develop that a little bit more, make that a little bit more user-friendly, if you like, this is now where we are as a cluster in Cambridge. So there are 150 clean tech companies now. So when we started, there were perhaps 30 or 40 in that space. There's that 800 million of investment within this clean tech region alone, There are emerging unicorns. This is a cluster adjacency. So I think you were there this morning for the semiconductors piece. There's a lot of read across between the technology space there and clean tech in terms of energy efficiency, and that's really strong in terms of developing the regional story around clean tech. There's also now, through the work that we've done, through our role in the region, developing the Cambridge and Peterborough Combined Authority 2050 vision for the region, in which clean tech is seen as an integral part of how that ecosystem develops. You've also got many more organizations that are contributing, many more emerging technologies, so Monimo, an AI design company, Niabolt, these material technology, Crown Estate developing an innovation district in the region which is going to be clean tech led. So what's happened in the 10 or 12 years since we've been around is the ecosystem has evolved, it's really grown. I don't know how much we've contributed. I think we've done some bits. But yeah, so it's the ecosystems grow and emerge, and they develop through our work, through the work of others, and through creating these connections across the whole space. And then finally, in terms of where the supercluster has got to, so we now have events with EDF in Paris. That's going to happen in the spring. That relationship came through the work that Sylvie described with the Cambridge Institute for Sustainability Leadership. They introduced us into EDF. Also, with Cambridge Consultants, they're going to be part of that delivery in Paris. We now have a relationship also with ICOS Capital. They're based in Amsterdam. So our event will be in Amsterdam early in the new year. And that's a relationship that we developed through our European program back in 2016. So the ecosystem kind of pays back, and it kind of comes back round in ways that you don't expect. We've also got London and Partners as part of our Clean Tech Venture Day, which is in July. And Cologne Development Corporation, which is the city development region, the city development company for Cologne, which is also within 4 hours of the region. So that's the extent to which there's this promotional and activational activity that a supercluster does. But a supercluster also does something else. It doesn't just describe a region, it doesn't just promote a region, it doesn't just create events for a region that activate. Actually, it also takes on some of the challenges of the region. So we've been working with Hydrogen East and the Institute for Manufacturing around developing the hydrogen economy across the east of England. And that's, again, what superclusters do. With intentionality, they take on some of the big challenges. So they don't just describe, they're active, and they work to actually solve problems, to create solutions, to bring forward ideas. The other couple of logos down the bottom, so Climate Tech Association, they're based in New York. They work with the Department of Energy. They're super interested. We've been talking to them about how we create those cluster-to-cluster relationships between the UK and the US in terms of sharing ideas and how we develop proposals and share knowledge across the kind of cluster community. And then finally, through Cambridge Tech Week, yesterday we met with CNN Chile. Now they're here recording the activity of Cambridge Technology Week, but actually they were really interested in the way something like a supercluster can aggregate technologies together, and they want to cover technologies that are coming from this region that are going to be applicable in Chile. So again, you start to develop these relationships with other parts of the global community because you have this agglomeration, because you have this ecosystem which really can operate at a global scale. Okay, so just very quickly in summary, so the importance of a strong clean tech ecosystem, depending who you are, there are different benefits. There are different things that you're really going to kind of feel and get from being part of that ecosystem. So entrepreneurs, ecosystems generate, incubate, accelerate, and scale innovation. So if you're an innovator, then get involved in your ecosystem. That is how you're going to grow. That was our experience as an organization. That's what we see in terms of the organizations that we work with. So for universities, it's about spin-outs, research, collaborations, and hugely importantly, impact. You can show your impact by the way you interact with other parts of the community, but other parts of the ecosystem, that's working with state, whether it's working with corporates, or whether that's working with entrepreneurs in the investment community. Investors, you create co-investment opportunities because we pull them together when we run these events, such as Clean Tech Venture Day. So you can find somebody that can invest in one of your companies, and also portfolio support. So your companies are eligible to be part of accelerators to benefit from the wider opportunities that ecosystems throw up. Government, economic growth now and in the future. So that's what Cambridge and Peterborough Combined Authority are interested in. They see that they need to create jobs across the region. It's also what London Partners are interested in. They want to bring companies into London. It's what Cologne are interested in. They want to bring companies into their ecosystem. So ecosystems are working for everybody. And finally, corporates, technology scouting, corporate venturing, collaboration and partnership. So many, many benefits for corporates. You can find emerging technologies. You can find opportunities if you have a CVC arm to do investment. And you can create collaborations and a partnership across the whole ecosystem map. Okay, so we are community building. So please do join the supercluster, follow what's happening. And yeah, if you'd like to know more, please do come and find me. Thank you very much.
Thank you, Sam. We all parts of this ecosystem. We can all contribute. So yeah, join, talk, connect. Now, what are the challenges and opportunities for the startups to grow in the climate tech sectors? I would like to invite Catherine at Cambridge Consultant and the panel to come and discuss.
Hi everyone, good afternoon. Welcome to this session. It's about scaling climate tech, how to accelerate deep tech solutions to the market, realizing business value and delivering transformative positive impact. So what could be better? I'm Catherine Jose. I'm the head of sustainability for Cambridge Consultants. For those of you that don't know us, Cambridge Consultants is really one of the founding members of this Cambridge technology ecosystem that we've just been hearing about. What do? We call ourselves a deep tech powerhouse. What does that actually mean? It means that we're a bunch of engineers, scientists that come together with our clients to really push the boundaries of what's possible with technology and deliver solutions into the market that really change markets. So it's a really fun place to work. We get involved in some quite exciting projects, and obviously it's a really great place to work on climate tech because we've got a really huge toolkit of capabilities that we can apply to solving some of these challenges, which are difficult. That's me. I've got a brilliant panel, which I'll let introduce themselves, and then we'll get into our discussion. So,
good afternoon. I'm Ian Anderson. I'm a partner in PwC, and I'm responsible for our UK ESG technology and data strategy and vision. I also sit in our global board, and as part of my role, it's really to make sure that we bring the best sustainability, climate tech to our clients and make sure that we are solving the problems that they have in transforming their organizations to achieve their corporate objectives around sustainability and also the regulatory responsibilities that are now emerging that they have to report against in alignment with the regulation that's present now in various territories across the globe. And it's nice to be here this afternoon. Thank you.
So, hi, I'm Oliver. I'm an investment director at a group called Future Planet Capital. So we're a VC group. We've got about $400 million under management, and we invest only in technology that's going to make the world a better place. So that could be healthcare, clean tech, ed tech, the whole range. My actual particular job is to manage biology-based investments. So I invest at foundation through to seed Series A in companies that are using biology. So again, that could be a gene therapy, it could be a trait engineering company, it could be a biomaterials company, it could be an oil company that's making sustainable aviation fuel. So we have a whole range of interests, unified by complicated technology and really big ambitions. So we don't do B2B, we don't really do, B2C, we don't do stuff that is pure play software. We're interested in complicated technology where you can get a demonstrable benefit by bringing the tech to market. Nice to meet you all.
Thanks. Hi, good afternoon, everybody. I'm Paul Beastall. I'm CEO at Hutan Bio. We are a Cambridge headquartered startup that is bringing together unique biology and challenging and difficult engineering to help decarbonize long distance transport. So we are using algae to grow low-carbon diesel that can be a drop-in for shipping and also refined into sustainable aviation fuel and for heavy land transport. These are all sectors that are really hard to decarbonize, have long asset life, and no matter what people say, electrification won't work because the batteries are just too big and heavy. So we're focused very much at the technology angle of delivering both economic and environmental benefit.
Hi everyone, my name is Miha and I'm the co-founder and chief scientific officer of Better Origin. We are a Cambridge-based sneak out, if I can call it that, a deep tech in the insect bioconversion space, or in other words, insect farming. We turn food waste into sustainable animal feed, pet food, and various other things by effectively using maggots as the conversion vehicle. So yeah, my interests obviously run in biology, which I cover within the business, but also more and more into various areas of regulation and how we can incentivize these changes that we need to see in terms of clean tech.
Lovely. Thank you to the panel, and thanks especially to Paul for stepping in at the last minute. Anyone who's got eagle eyes will have noticed that Frank from Quays Energy was supposed to be on our panel, but unfortunately he's been struck with COVID, so particular thanks to Paul for stepping in. So, to get started our discussion, when we talk about this deep tech interface with climate tech, a challenge I often get faced with at Cambridge Consultants is essentially what's the point? Deep tech is very exciting, it's very cool, but the climate crisis is an urgent crisis. We need to solve it quickly. So are these solutions going to deliver an impact in any timescale that's meaningful? And of course, if we're developing new technologies, they're not going to have any impact until their scale. So one thing that is super important when we're thinking about that route to scaling is, do these solutions really meet a market need? So something I want to explore with the panel is, how do we ensure when we're developing these technologies that they are really meeting that market need so that we get that mass adoption and they're going to solve the problems that we're trying to solve? I might as well start left to right now.
It is a really, really interesting challenge, and on almost a daily basis, I get organizations reaching out to us to say, we have a technology or a solution that we think will target this sector and solve some of the climate challenges that organizations have. And when we take them to our corporate clients, typically, it's often the case that they have a solution that doesn't marry up and match to the corporate objectives that have been set by organizations. And trying to bridge that gap is often one that is very, very difficult to do. And understanding the inner workings of a corporate and taking a solution to them is something that the startups are really challenged with. So in many instances, we will work with them to help them adapt and adopt the technology that they've got with the insights that we have with those organizations. But really, having something that is looking for a problem is never going to work. There is a real necessity to understand what are the objectives that organizations have that the technology is being positioned towards.
And Oliver, I guess this is something you look at quite carefully when you're making your investments.
It's the existential question that all VCs face: is the market big enough? I mean, I was in the scale session this morning, and Herman Howes, I think, listed three things. I think if I get in the right order, said his first thing was how big is the market. The second team is what is the star in the team that you're backing, and the third thing was the IP. And I thought he's absolutely right, because ultimately, most stuff doesn't work, put it this way. VC backs risky technology, and it probably won't work. But if it does work, it has to make a big difference. So the first question is the technology and the problem it's solving really big enough? And if it is a big enough problem, then I think the money is available. You can find the VC for the different stages. I think I like your point to corporates, but of course, there's another alternative. You don't have to sell out to corporate. You can try and take yourself through. And actually, in many respects, it's a shame that Quays isn't on the panel today, because when we had our pre-meet, he made a really good point that Quays, which is a kind of basically a microwave that can drill very deep holes, get geothermal energy, doesn't want to sell to corporate. They want to be the corporate. So I think it's an ambition thing.
So actually, I always say, my time at Hutan Bio, this is the first startup I've been engaged in where I have no doubt there is a market. If I can meet the needs of the current market to move things around the planet, and I can help them reduce their carbon emissions, great, they will buy it. What I need to do is prove product market fit. So actually the risk is all on, actually, is my product the right product to meet the needs of the market? And that comes down to early engagement, testing. And again, I'm quite lucky that parts of my market are regulated. The next question I know, but that means we've got standards we can look at and things like that. So we can do things to start that early engagement. And actually, it's a bit like selling to VCs. You need to get out there, you need to talk, you need to get the hits, pull yourself together, stand up again, tweak slightly, and so shape your product early. The worst thing you can do, and I've been in Cambridge now for nearly 25 years watching people do this, is design the perfect solution and then go and do the big reveal and tell the market what you've got. That's the guaranteed way to fail.
Miha.
So I very much agree with what Paul's just said. You know, it's a journey and you need to be conscious of the market as you go through it. Perhaps a point I could add to that is also the broader policy and regulatory landscape. So, you know, governments have committed to very ambitious targets by 2050, but there's, at least in the food sphere where we are, there's a bit of a lack of steps how we reach that 2050. So we tend to pass that problem sort of down the line, and obviously governments tend to work in 4 or 5 year terms. But we need to really start being ambitious about how we set these kind of milestones and checkpoints, because that will further help the market. A lot of the reliance now is on corporates that, for example, you know, have set up their executive remuneration in a way that's driven by sustainability. So those are the ones that we tend to see being a little bit more active, really putting the money where the mouth is. But by and large, the sphere is still at the beginning. A lot of people are figuring out what clean tech means. How do you decarbonize your own organization? And I think governments have to probably play a bit more of an active part to get us to that next stage and support businesses like Paul's and mine and many others in this room, I'm sure.
That's a really nice segue into the topic of regulation that I did want to touch on. And we work as well as in these more emerging markets, in more established markets. And in some cases, like consumer electronics, we're really seeing that either the regulation that's coming or the threat of regulation spreading from one sector into another is driving sustainable innovation. And we are seeing our corporate clients taking action. But as you mentioned, and we've talked about this earlier, climate tech is just this horizontal, it's this collection of things that hangs loosely together, and I think regulators have a lot of trouble keeping up with it. So that's probably always going to be the case. The regulations are always going to be lagging behind what you're trying to achieve. In some cases, a bit different, nice contrast between your two organisations. But Miha, how do you start to make progress and get there, knowing that you're probably always going to have that problem?
I think you're absolutely right. You know, this technology, when we say clean tech, it's usually a little bit ahead of where the regulators are going to be. I would also argue a lot of, let's say, the innovators in the room in this sphere, you know, their understanding of the problem, of the scale of the problem, and what it's going to take to solve it is probably a little bit more holistic than someone who might be, you know, doing a 2-year stint in some part of the civil service. So there's a big kind of knowledge gap there. But I think, you know, we have done this stuff successfully, so it clearly can be done. If we look at things like solar, if we look at things like anaerobic digestion or offshore wind, you know, these things now can stand on their own 2 feet. They are competitive. They can go against, let's say, fossil fuel derived energy or, you know, composting or more traditional waste management. But the way they've reached this point is by policy being supportive of it, especially in the early stages, to allow it to scale and reach that critical mass, which allows these type of technologies to take the next step. So sustainable aviation fuel is an example of this. There's been a lot of policy support for it. There's been kind of increasingly mandated sort of targets companies have to hit. So, you know, sometimes it doesn't have to be all public purse should pay for it. I think we're all aware that the public purse is maybe not as deep as we'd like it to be to solve this problem. But oftentimes all it takes is ambitious policy and courage in setting it out, because the fact is the market will adapt to it and sustainability will become more affordable and status quo. And I think that's where we have to go.
Paul, are you finding the regulation helpful?
Yes. actually, to be honest. And I think Mead has just stolen most of the thoughts that I had, which was actually regulation is part of it. No, I totally agree. Policy is actually the precursor to regulation. And actually, I think a lot of the work that I'm doing at the moment is trying to also talk to people that make policy. So regulation is a response to the direction. I would always say policy is strategy and regulation is tactics. And I think in my specific markets, particularly in the marine sector, there's some very ambitious targets around decarbonisation that are coming either from the International Maritime Organisation, the EU, some really impressive things coming out. So the EU are going to make it illegal to use food crops to make biofuel. That's great for me. I'm not using food crops to make biofuel. It's also great for people that live in the third world and struggle to get food. So, there's this balancing act, and one of the key roles for policy and regulation is to make sure that point solutions don't have unintended consequences. So there's the market driver, but there's also the whole kind of reputational piece. As a relatively nascent industry, we are going to get some things wrong, and there are going to be unintended consequences. And I think actually working with regulators to help drive that is really important. And I think particularly in decarbonisation, the thing that worries me is fragmentation. So there's regulation in Europe, there's different regulation in the US, there's different regulation in Asia Pacific, the Australians are doing something else. And actually, to really have a difference, you need to play on a global scale. And actually the bit I think is missing is alignment at a higher level, but we've not shown great progress as mankind in general at doing that previously.
Anything to add from either of you?
Oh, wow. So look, I mean, you guys are doing it day to day. For us as a VC point of view, there is that slight worry, which is regulations can change. I think it doesn't change in such a positive way as your technology. But it is an interesting conversation to have a little bit in your brain as an investor, which is how long is this particular regulation going to stay in place? So I think we do think about that a little bit. The classic that I was shocked is when you get an electric car, they have different plugs in different parts of the world. So would you be the company that invests in the unified plug, or would you be the company that waits for the policy to change and put in place the same plug across the world? I don't know. But no, look, I think they summed it up. And we invest in this space. We like that certainty that there's going to be a pull from the consumers driven by regulatory change which the corporates respond to. I think that's really important.
It is really interesting how dynamic this whole space is moving. If we go back 24 months and the priorities and the objectives that we had in developing technology in this space have changed, and it is policy and regulation that is shifting the focus of whether it's corporates, consumers, or the work that we're doing more broadly, and the agility that we need to have around where our focus is, alongside that regulation and policy is really essential. We're seeing organisations who have invested heavily in particular technologies and not able to get them off the ground because regulation and policy has directed the focus for organisations in another place, and therefore their irrelevance is someone else's significant relevance in the technology that they're delivering for the problem that's in front of us today. Over the last 12 months, we've seen just the UK government change some of their environmental focus and policies. And again, that has had a bearing on where people are going. The EU regulation around CSRD, again, that is driving a lot of focus and attention on regulatory response rather than maybe corporate objectives around what they're going to do by 2030 to decarbonise their organisations. So there is definitely a bit about where we place our chips and the focus on the activities and the investments that we make.
Thank you. We touched on it earlier, but I would like to have a bit of a discussion about where, as startups and scale-ups, the journey takes you. So, as we heard from Serena earlier, climate tech solutions, I liked the putting a number on it, 58% hardware, often very capital intensive. So what implications would the panel say that has for exit? We've talked already slightly about different exit routes, and also with that in mind, thinking about what that means in terms of your milestones that you're setting that might be in support of getting that next funding round. So maybe start with Oliver as the VC view on this.
So I think it really depends on what you're doing. I think if you think about exit as in when the company stops doing it and somebody takes over responsibility for it, or when the company has floated and it becomes a revenue-generating business. So I think it depends on what sector you're operating in. I don't know what your plans might be in 5-10 years' time, but I think it's probably unlikely that you're going to go to market, maybe I'm wrong, as an IPO, as an oil generator. You might go to partners that can operate the facilities. Whereas you might take a company, Quasar is an example, right, that has one piece of technology that it thinks it can take to market, because of different ambitions. So, I mean, I invest in, as I said, companies use biology. And so some of them, you'd never expect them to get to market via an IPO at all, and their risk points stop much sooner. There's a natural acquirer which will buy the technology with one smaller proof point. Healthcare, for example, we all know that you get to end of phase 2, 3, and you can sell it. If you're making a materials company, do you have to take it to market? Do you have to show the world that the customers need it before somebody acquires you? So I think that is a question that we ask a bit when we invest, because of course it changes how many rounds you have to go through, how much investment is raised. But there are, I think, there is increasing awareness that different companies need to get to different points, and the investors that come into those companies at that stage are cognizant of it as well, so they're comfortable with that risk.
And are you seeing that the climate tech companies have that journey fixed quite early, or is there a bit of figuring it out on the way?
I'd say never say never, right? Yeah, one of the things you want in a team is to be nimble and ambitious. So if they see a route to a much bigger exit by doing something extra, then please chase that as hard as you can. But I think it is nice as an investor to have a conversation with the team where there's a strategy. That's really interesting, because it shows they've thought about it, and that they've got a route through to 7-8 years' time when they might exit, or ideally 2 years' time when they might exit.
Paul, you've kind of been primed to give your plan. Are you going to tell us?
Yeah. I think Oliver's probably right. I think Hutan Bio is unlikely to go all the way, partly because the environment we're reaching peak oil is forecast to be next year. There's going to be some very large operators that have shrinking businesses and skilled workforces. Why would I build a workforce of 20,000 people across the planet at the same time that Aramco and ADNOC and people like that are making 20,000 people redundant? That doesn't feel like the lowest cost, highest value route for the ecosystem as a whole. I think for me, the more important thing is actually, whatever, as a deep tech, we are going to need a lot of money, and we can't just put out a minimum viable product and go and float on AIM. That's just not going to happen.
No, that won't work.
So what we need to do is we need to get a lot further, as Oliver said, to the proof point. So one of the things that's really important for me is moving from risk capital to project capital. So I need to take technology risk and market risk off the table as soon as possible. So I'm not taking equity funding to build oil farms, because that's the wrong model. At that point, I need to be borrowing money from people that are used to investing in infrastructure. Macquarie and Teachers' Pension Fund in Ontario, those sort of classic infrastructure investors. If I can get to that point, it's almost what's the best deal at the time to then have an exit. For me, the worry is how do I get to that point? And that's several years down the road, and it is pivoting. We have to become, I think, a relatively mature business before we can exit. And that's the key challenge, and then it's a lovely problem to have.
But that's interesting, because you are taking it to revenue. So you are having to get to be quite a late-stage big business operating sites globally, which is different to some other technologies that we invest in, where there's a different risk point that you can get to. So I think that's the point, right? And once you've got there, then it's like, we're in reach of being an IPO.
Wouldn't it be a great problem to have?
Wouldn't it? Yeah,
I'm kind of looking forward to that conversation with the board in due course. Absolutely.
I think maybe part to add to this is also the scale element. So I know in our sector, and I'm assuming it's similar with Hutan Bio, relevant scale to demonstrate the technology is not an Eppendorf tube. It is tons of product. That usually means there's a significant capital expenditure, CapEx, which, all of us probably going to be on that page, but it's not really the VC's primary appetite. Maybe 2021 and beforehand, there was a little bit more allowance for it. But over the past few years, CapEx investment from traditional venture capital, even patient venture capital, has sort of reduced, which means that a lot of this hard tech, clean tech, is sort of starved of capital needed to reach the scale where an exit becomes an opportunity, either for partnership or corporate sale or float, whatever it is. Which is why I think, from the earlier presentation, we've seen that what's doing really well at the moment in clean tech is software. it's carbon tracking, it's authentication. These businesses are doing really well at the moment because they fit more of the traditional sort of venture capital SaaS model. And I think, how do we cross that gap? Because we definitely need software, we definitely need these solutions. But if we don't invest in some of the hardware needed, we're never really going to help decarbonize some of these hard to decarbonize sectors. And who sort of blinks first here? Is it the corporate? Is it sort of government regulation? Is it venture capital? It's a bit of a Mexican standoff at the moment, I feel.
So what we're seeing is you're seeing CVCs come in that space quite a lot. Corporates that have got a strategic interest rather than just a financial interest, and then sovereign wealth funds that can think really big. That will write a check for $1 billion and it's a drop in the ocean. But then, of course, the problem with accessing that sort of money is you do have to get to be big enough to get that kind of check to start with. So that CVCs, I think, operate a lot there. I mean, you're correct. Traditionally, VCs hate capital because you're spending on something that if it doesn't work, what do you do with it afterwards?
Yeah, exactly.
Yeah.
And would you agree?
Yeah, I was
you're
gonna
working
say-
a lot with the corporate side.
Yeah, I was going to say, I mean, a lot of the points that Miha's making around, software is at the forefront. It's not hugely capital intensive. It's also the thing that's in front of corporates' eyes at the moment. And the big infrastructure projects are just so capital intensive that they shy away from it. They've got investment programs that run over 10, 25 years. And to Oliver's point, if it doesn't work, that's a lot. It's a significant investment that just walks out the door. So yeah, I mean, I think it's what's in front. What's easiest is where we are today, and getting that significant investment around infrastructure is really quite hard at the moment. But it's going to have to move at some point. It's not.
Yeah,
it's deferring the problem rather than solving the problem at this stage.
Yeah, I have to ask, as my curiosity has piqued in terms of the scale of your ambition for Better Origin. I can sort of, for Hutan Bio, visualise it because we all understand the oil industry. It needs to be getting to that kind of mega scale. Do you see the same for...
Yeah, it's very similar, right? The UK sort of produces around 10 million tons, I think was the recent RAP report of food waste.
Yeah.
I mean, it's a huge number, right? And if we're talking about these kind of first of a kind demonstrators at industrial scale, they might take something between 50,000 to 100,000 tons. So it is very much a drop in the ocean compared to the scale of the problem. But certainly the challenge is big, and we're talking just about the UK. Globally, this is 1 billion tons a year type problem. If we look at the emissions, it's gigaton type potential. How do we close those gaps? I think that's going to be a question mark, but there's certainly things moving, so hopefully we get to see this next stage, because part of the startup game is surviving to the point where those things change.
And I do think if I stop and think too hard about what success looks like, I won't start. You just need to focus. And to Ian's point, actually, what we have to do at every stage of our journey is take risk off the table, which means we can attract the next scale of investors. People like Oliver are great because they're early stage investors. They understand technical risk and they expect technical risk. As you get to the stage where suddenly you're raising $50 million, then actually there's a far greater expectation that you're going to succeed to the next stage. And so actually I think it's really important to be methodical from day one. These are the things we need to take off the table to open the next gate, and then the next gate. And I think that's
crucial. We always ask that. I mean, it's a fundamental basic investment thesis that you know what this money is going to get you to, and then also that somebody else external to the company has told you why that too is a good point to get to. We always try and talk to the next investor and say, if they can show this, would this be something you'd look at? Yeah. Because otherwise there's a huge hole in the ground that you've got to try and close.
We've been trained to hear software companies talk about pivoting. And actually that's much harder to do as a deep tech, as a hardware business. So you need to be much more rigorous early on being sure you're on the right path.
And software companies are just a marketing risk. The software will work. The question is whether anybody buys it. And that's all it is. It's a marketing game.
But I think on the deep tech piece, those organizations, those startups that solve a solution that can scale on a global basis are the ones that are likely to be way more successful. But that set of challenges around different, back to the point around regulation and policy, is so variable across the geopolitical landscape that we have on a global basis. So those organizations that find that thing that makes that difference on a global basis will inevitably be more successful, I would suggest.
Well, I've definitely been making a few notes, so Sylvie will be happy if she tests me later. But you've been a very nice panel. You're all agreeing with each other, so I haven't managed to kick off any arguments. So sorry from the entertainment perspective. But what we will leave you with from the deep experience of each of these panels is just one nugget of advice. So what I'm going to ask you for, and I feel bad because whichever end I start at, it becomes harder for the other. But based on all your experience of either being at the coalface of a startup, which is a terrible turn of phrase to use on this panel, but I think you get my gist, or in terms of your role in supporting and facilitating that, what is the piece of advice you would give to anyone going on this journey who's thinking of how do I get to that next stage of my business? Go for it.
So I said it at the beginning, being clear about the problem that you are trying to solve and investing in is absolutely essential at the outset. But being agile and moving with the market, particularly in this space, is really important. If you set your stall out and you're going to run for 6, 12, 24 months, and do, I think as Paul said, the big reveal, you'll inevitably fail. So, be clear on the problems that you're solving, but also be, cognizant that the market is moving very, very quickly in this space.
Oliver?
So taking as read that the market is big enough to be venture capable, I think showing awareness of your competition, that's the key thing. It's a huge red flag when I talk to companies. And the classic is they have a little matrix, and they're the one on the right that ticks all the boxes, and nobody else manages to tick all the boxes. And you think, really? Is it really true that nobody else in the world has got something similar? So I just think that's a really good sign of maturity and awareness of the world, that you're traveling alongside other people, because it's very unlikely that you're the only founder in the world that's identified such a big market that nobody else has thought of. And then what we dig into is, why are you going to beat the competition? So the other part of that is to be really clear. It could be a paper exercise, it could be entirely theoretical, but as long as you've got a clear reason why your technology is better than the competition, be that the robustness of the science or the techno-economic model or something, then that's the key from an investment point of view, I think.
Paul?
So for me, I think it's all about telling the story. So a lot of investors in climate tech don't understand all the technology because we've already seen it's a horizontal. It's an incredibly broad field. They understand the ambition, or you get classic deep tech investors. I wouldn't say they don't care, but they're not driven by the ethos. We will be successful in abating carbon by building successful businesses, and we will do that by telling the story that gets people to back us.
Yeah.
Well, to follow up for me, and I think the biggest one is agility and adaptability. As a deep tech, be it in clean tech or any other sector, it's going to be a multi-annual journey. You need to be able to adapt as you go, because things will change through the years. What you set off as, it's probably going to get pivoted and refined over the years. I think that's probably the biggest one. The second one is, don't be afraid to be a generalist. Generalism is needed in this sector. So I started kind of this thing as, very much bio nerd. Keep me in a lab, don't show me anything else. But you realize over time, hey, you need to do a little bit of market and commercial understanding. Regulation looked very taboo in the early days. But nowadays, it's probably one of the biggest impacts, not just for our sector, but hardware, deep tech, more generally within the sphere. So yeah, don't be afraid to leave the lab code at home and venture into unknown.
Well, thank you. I'm really impressed you managed to all come up with a very distinct theme of your advice and no overlap. So that concludes our panel. I'd just like to thank you all for coming and listening, and I hope you found that helpful. Just a reminder that we've got the networking break next, so you can all have a chance to grab our panel members and grill them even more deeply than I've managed to. So let's, I think, just give our panel a really big round of applause.
Thank you very much to all of you. We're going to have a 30 minutes breaks. Before that, let's clap again, not only for the panel and for Catherine, but also for the speakers. I hope you've learned something, and let's go and network. And come back, because after that, we're going to change the pace. Welcome back. I'm pleased that still quite a lot of people in the room, so grateful for that. So for this second half, we're going to change slightly the format, and we're going to go into a deep dive into two sectors that are part of the climate tech. One of them is energy, and the second one will be new materials. So the format will be first to have an expert setting the scene on energy and 3 pitching companies, and we repeat that for the new materials. So first of all, I would like to welcome Serena from the Clean Tech Group, as well as the 3 pitching companies. If you would like to take a seat here, Serena will start, and then you will come. You don't need me to introduce yourself. You just follow the rules, and I will help if needed. Okay, so let's see what we have in new energy, in energies.
Ooh, yeah, it is on. Good. Well, I hope you're all refreshed. I hope you've all had a good tech week so far. My name is Selena Law. I am a senior associate at Clean Tech Group. We are a research-focused company at the intersection of innovation and venture capital. So in my day-to-day job, this is what I do. I speak to startups and venture capitalists alike. And so following on from today's theme of deep tech and also scaling up, I wanted to take a quick look at the venture landscape and see where we are, really. So without further ado, so I think it's not really a surprise to anyone that the overall investment is down by quite sharply. And mind you, I'm aware that you may have seen different kind of investment figures today. So bearing in mind that this is just kind of nascent technologies based on our taxonomy. So taxonomies might differ. But yeah, 2022, obviously a record year for investment, and energy and power coming in really strong. So ever since then, 2023, energy and power has been kind of underpinned a little bit by IRA. Quite strong investment there, but also these numbers include China investments, so those Asia numbers have really bolstered 2023. But then further out, this year, inflationary pressures across the board, troubles in Middle East, US presidential election, we're hearing inflationary pressures across the value chain, which obviously is making all projects, all scaling up much more difficult. And that is really reflected in the number of deals that's dropped off, as well as almost halving of the investment in the energy and power segment. But then actually kind of digging a bit deeper into it, you could see that seed and Series A into overall kind of clean tech space has remained roughly flat since last year, and these numbers 6 months into 2024. But then Series B figures have increased quite a bit, while growth equity has decreased. So what's happened here partially is that the IRA has underpinned more mature technologies, so they can now access kind of debt financing, project financing, etc. So that kind of decline in growth equity, kind of Series C, anything upwards there, this is partially actually because the later stage developers have accessed just different types of capital rather than venture finance. Right, so I'm going to come back to that slide. And who is it that is getting these venture dollars? So something to kind of bear in mind is that the really early stage developers, startups, have not really raised much financing this year at all. And I guess that's also because that's where the risk is, but also that kind of segment it seems to be quite well bolstered by government grants in the UK, US, Australia, EU, so there's a lot of money kind of covering that very, very early stage startups. And then when you look at the kind of later stage, TRL9, especially in deep tech, you can see that that's kind of really kind of declined compared to 2022. And again, this is not necessarily reflective of overall kind of downfall in financing, but it also, from our data, shows that that these later stage innovators are actually accessing different kind of finance. And the Series B has been quite strong, so we're talking about this kind of valley of death between Series A, Series B. Actually, I'm not quite sure that is 100% reflected on these figures. If you look back, you can see that Series B has increased, and that's because a lot of the investors in Series A have already kind of chosen their companies. These companies are now scaling up, particularly in energy, and so they're participating in Series A and Series B. This is particularly true in technologies like hydrogen electrolyzers, green hydrogen, which require kind of large-scale manufacturing facilities. But for deep tech, actually, it's not that bad looking picture at all. And I'm sure you've all heard about this, that the share of deep tech investments has actually increased by quite a significant margin. As you can see, in 2019, 2020, the share of deep tech investments in overall climate tech investments was just 8%, whilst it's now up to 18%. So there has been quite a significant shift in that perspective. In 2022, we saw a lot of investment in just digital solutions, and that has now almost kind of dropped off, especially in energy and power. Sorry, I should clarify that. And now, bar for some climate resilience and grid resilience technologies, typically you need to have a hard tech element to your technology, say sensors, or it can't be just a digital solution. And as you can see, we've also seen some areas that are quite strong still. So hydrogen, as I mentioned, and electrolyzers in particular, as they're scaling up, they are still managing to attract quite a bit of venture dollars. Also, continued interest in thermal energy storage and mechanical energy storage. We've got Cheesecake Energy coming up. I'm sure he can tell you all about it. So overall, it looks like quite a bearish picture. But once you dig deeper into the numbers, I think it's clear that the deep tech solutions are still performing quite well. And with that, I am going to hand you over to our innovators. I hope this was informative and useful.
So, yes. So now we're going to have a 7-minute elevator pitch. And Paul, you're welcome. You start. 7 minutes. I'm sure you've got enough to say and plenty of things to.
I've got plenty to say.
Yes.
Excellent. Thank you, everybody, and good afternoon again. So I'm just going to try and introduce you very quickly to the problem space that we're working in Hutan Bio. As I said in the session before, we're bringing together engineering and biology to help decarbonize long-distance transport. And fundamentally, we're looking at 3 main sectors in that space, so heavy land transport, shipping, and aviation. And they all have a number of things in common. They are very capital-intensive businesses. They have assets that are running for a very long time, and that's really important. And they are highly utilized, which means pulling your assets out to retrofit and upgrade to ammonia or hydrogen or anything like that doesn't just cost you the capital of doing that, but there's the opportunity cost of not having your asset available. They also consume vast amounts of oil. Between the 3 categories, it's nearly 9 billion barrels of oil a year, which is, from my view, quite a lot. So what we have is a situation where it's hard to decarbonize legacy infrastructure, And remember, people are still building kerosene aeroplanes, they're still building heavy fuel oil ships, they're still ordering new ones. So this is a problem that's going to run for a long time. So we've taken the idea that the way to affect this challenge is to decarbonize the hydrocarbons. Hydrocarbons are the densest way of carrying energy for long-distance transport. So we talk about being a zero-carbon or a low-carbon sustainable replacement for diesel and a feedstock for aviation fuels. And we say that we are a disruptive biofuel, but without the disruption. And without the disruption is we drop into the existing value chains. So we allow legacy infrastructure to decarbonize by changing the input fuel. And I've already touched on this. Actually, the thing about long-haul transport is you need to carry energy a very long way. If you want to carry a ship from Shanghai to Los Angeles, two of the busiest ports in the world, you need to carry a huge amount of energy to move that ship. If your energy source is heavier, because you're using a different technology, that's less cargo. That changes the economics. Lots of people aren't willing to make climate change if the economics don't add up. You can't do battery-powered long-haul aeroplanes because they're too heavy to take off. If you look at trucking, in the Western world, maybe we can make some changes. If you think about South America, Africa, the Indian subcontinent, vast distances and very little infrastructure, we need to use the existing infrastructure that we've got. And how do we do this? Two things. First one is the biology. I've now got the challenge of explaining our biology advantage with our founder, Dr. Archer, sat in the audience, so I'm sure he'll mark my homework later. Fundamentally, what Hutan Bio did was turn the problem on its head. Most people start with the biology and try and find an application. What John and his team did is spend about 120 person years searching the world's tropical seas, taking samples of algae and then abusing them and seeing which ones survived the abuse. And the ones that survived are the ones that can cope with high temperature, high salinity, can cope with the highest levels of sunlight that are falling on the planet, and produce an oil that is very like diesel, a triglyceride oil. So actually, John and his team took 1.2 trillion samples, bobbing around in tiny boats, being rather ill from what I'm told. It's before my time in the company. And of those 1.2 trillion samples, what came out at the end, about 150 species of algae, 80 of them in the same family, in the same genus. And that's our core IP that enables Hutan Bio. But biology alone is not enough. What we need to do, I've forgotten my slide, or that's rather interesting. I'll come back to that. So in terms of route to market, what the algae makes is a heavy fuel oil that can go directly into ships. So this is something that can be extracted from the algae, sold directly into the shipping industry. It's also rather like crude oil, so it means it can be put into a refining stack and then used to produce low-carbon kerosene, what we also call sustainable aviation fuel, and low-carbon light fuel oil, so diesel for road transport. Also interestingly, we have a secondary revenue stream, which is the shells, the husks of the algae, are a high carbohydrate, high protein food source. We're looking at deploying in coastal desert regions. If you can't grow crops to feed your animals, actually you're dependent on imports. So a secondary carbon benefit is we will help countries grow food stocks for their agriculture locally. The reason I joined the company is this slide, which is actually I'm getting fed up of people driving global starvation through using food crops to make fuel oil. So we can feel like we're being environmentally friendly. People are starving in the developing world. Our algae grows in salt water. We use zero fresh water. We grow in deserts, which means we don't need to take up agricultural land, and where there's no deforestation because we're using land that is already not supporting agriculture. So actually, I think we have a very strong environmental position. And what we do is we build our oil farms in coastal deserts. So we're bringing together engineering and biology. We're using, it says here, zonal arrays is a big term. We're using lines of low-cost photobioreactors. These are very fancy plastic bags. James, who sat next to John, is responsible for designing those at the moment. We're just about to ship our first prototypes to our pilot site. And I think about it, it's like a vineyard. But rather than growing grapes to grow wine, we're growing oil. So it's lines of green on a vast scale. And these photobioreactors have a network control system. So this is, effectively, we're a smart agriculture business that grows oil, not food. And we deploy it in areas with high year-round sunlight. We have a live pilot site in Malaysia. So we're currently producing oil. This is a picture of our photobioreactors. Our first generation ones don't have any structural integrity themselves, so they're held in these vast metal cages. By the end of the year, these will be purely engineered structures, and all that steel will be taken away. And we're producing oil at the moment for testing with industry partners and against published standards. I talked in the panel about de-risking. This is the step we're doing to prove product market fit. And when I say coastal deserts, people are always like, well, is there enough land? We're targeting 5 key markets, so Australia, Chile, Morocco, Namibia, and Saudi Arabia. Between them, there's about 90,000 square kilometers of non-productive land that can be used for our solution. And we're hopeful to build our first pilot site, or to start building that during next year. Thank you.
Good afternoon. So I'm John. I'm the Chief Executive of Levidian, who are a climate tech company based in Cambridge. I'll talk today about 2 problems. We're talking today about myths. So these are 2 problems and 2 myths. One is the methane issue. So it's the less sexy greenhouse gas, right? Carbon dioxide is a big problem, but so is methane. In fact, it has a worse warming impact per molecule than carbon dioxide. And if you remove it, it can help us cool down more quickly. So I'll talk about methane. The second problem is one of perception. We have an issue where there's this artificial choice in people's minds between decarbonisation on the one hand and growth, prosperity, and innovation on the other. I'll talk today about how you can achieve both of those things and how to drive real change. We have to see that decarbonisation will lead to innovation, will lead to more prosperity, and we don't have to choose between them. So those are the two topics for these 7 minutes. The solution to that problem that Levidian has is called our loop system. Here's a picture of one on the screen. Loop is a pre-combustion carbon capture device that does 3 things. It captures carbon from methane gas, literally in solid form. It makes hydrogen, which is a clean fuel, and it also makes graphene. So the way that we capture the carbon is we apply microwave energy to the gas flow, run it through a clever nozzle system that was developed from Cambridge University scientists, and we pull out the carbon in the form of graphene material. I think it's madness to talk about carbon capture by pumping carbon dioxide under the sea. What a waste of an amazing resource. Carbon is hugely valuable. We should be utilizing it, not burying it, and we'll talk a little bit more about that. So that's our solution, and this isn't a theoretical solution for the future. This is being used right now, today. So anyone go to Glastonbury Festival this year? Any music fans? Nobody? Yes, one in the middle. So there's a loop system at Worthy Farm, which hosts Glastonbury, and we're taking the methane from their cow waste, and we're pulling out graphene material, and we're making hydrogen, which goes through an engine to power the local village. We've also got these loops on wastewater sites up in Manchester, an ADNOC gas processing facility over in the Middle East, industrial sites in Luxembourg. This is happening today. This is not a theoretical thing for the future. So that's our solution. Now, you might be familiar with carbon capture. You may know a bit about hydrogen. Graphene is often the least known part of what we do. And graphene, think about it as a wonder material additive. So it's a carbon lattice, single layer or a few layers that you add to different materials. One example is concrete and cement. So between them, making concrete and cement accounts for 8% of all global emissions. If you add graphene to that material, you can reduce the carbon intensity of that concrete and cement by about 30%. So by pulling the carbon out of the gas before it's burnt, by embedding it into concrete and cement, you effectively make it stronger, make it last longer, reduce the need for steel rebar in that concrete, and you have a decarbonisation benefit. As I said, why bury this carbon under the ground when you can use it and have a secondary benefit rather than just wasting it? Another nice example is your car tyre. So your car tyre probably weighs about 6 kilos. If you add about 3 grams of graphene to that car tyre, it will last 30% longer. It will just wear out less quickly. So you'll have to make less tyres, therefore there's a huge carbon saving there. So graphene is really exciting material, has been largely in the hands of academics looking at How do we use it in all these funky ways? It's really been a solution looking for a problem for a long time. The problem graphene has found to solve is the decarbonisation of our infrastructure. And that's why I talked at the start about how you can decarbonise and innovate and prosper together. Graphene lets you build new products, stronger products, things that do new things and operate in different ways. So you don't have to force decarbonisation or growth. You can choose both. And just to, click on to the next one. I talked at the start about how there was this perception that you had to choose growth or decarbonisation. Because the loop system does three things, makes hydrogen, captures carbon, and makes graphene material, all three of those have an economic benefit. Graphene is hugely valuable. Per kilo, you can charge hundreds of pounds a kilo for it. And so if you want to drive really low-cost carbon capture, really low-cost hydrogen, because you're making this graphene material, the economics offset each other. So I was at a breakthrough energy event in London earlier this summer that Bill Gates hosted, and he talked about a post-subsidy world where we have to get to a point where clean technology works without a subsidy. And this does. And this does that because you're making this graphene material that has real value. I remember when I came to Cambridge as an undergrad years ago, they said, if you get a Cambridge degree, it will get you an interview, but you won't get the job. You have to be good in the interview to get the job. Equally, decarbonisation, if you tell a company you're going to help them decarbonise, they'll talk to you, but unless it makes economic sense for them, they won't adopt it. And that's the key here, I think, is how do you persuade these big companies, people who make cements and concretes and tyres and battery cells, that you can help them get better, make their products better, create business value and decarbonise at the same time. So I think there's real opportunity for the economy to use new tech, to innovate, to decarbonise and to do new things. It was actually quite depressing looking at the charts on climate tech investment. Even though compared to others it's not in a great place, it should be doubling, it should be tripling every year. Well, what a shame there's not more momentum behind these technologies. And this is one where there is. So we've raised $50 million over the past 2 years to really scale this up. We've created about 100 jobs in Cambridge focused on this clean technology, and there's a load more of this to come. So that's a quick run through what we do, why I think those two problems of decarbonising methane and ending this false choice between decarbonisation and prosperity are fixed. We're already rolling out the cheapest hydrogen on the market because we're able to create this graphene value as well. You see it in the real world. Anyone's at Glastonbury next year, you should see it there. And yeah, this is an example of a Cambridge-based tech that's out there at scale. Thank you very much.
Good afternoon, everyone. So my name's Mike Simpson. I'm the Chief Commercial and Product Officer for a company called Cheesecake Energy. You may be wondering about the name. I'm going to keep you in suspense for now. I am responsible for the name, so I'll apologize if anyone's tummies are rumbling. The work that we do is on energy storage. So we're looking at a different approach to energy storage, particularly for the longer durations. Now, we are talking to a lot of different customers that are facing challenges around decarbonizing. They're facing challenges around the cost of energy. A lot of them are looking to electrify. Brilliant. We like electrifying things. But then they come to ask for more electricity in order to electrify. And the grid says, well, yeah, sure, you could have more electricity. Would you like it in 2032 or 2033? And that's not a great message to be receiving when we've got a massive climate crisis on our hands. Now, energy storage can be part of solving that problem. We have an energy storage system that's based on storing heat and compressed air. Now, these are pretty readily available sources. We're not going to run out of air anytime soon, and creating heat is something that we do very, very easily. The system is designed to be incredibly sustainable. We're using proven industrial hardware in our system. This is not about mining rare elements. This is not about facing massive geopolitics to get hold of the resources you need. For our system, you basically need steel, some air, and a few rocks. It's a modular system. We're delivering 200 kilowatts of power and 5 hours or 10 hours of storage, typically. It's completely containerized, and we're targeting a 25-year service life. That's pretty important when you care about sustainability. You want stuff to last. If we're having to replace stuff that we're installing every 10 years or so, well, it's questionable whether we're really delivering on our goals. The way the system works, we take electricity from renewables or from the grid, use it to run electric motors. The motors drive piston compressors. We compress air, and that air, as it's being compressed, it heats up. So we capture the heat and we capture the air. And we store the air in pressure vessels, and we store the heat in our thermal store. When we want the electricity back, very simply, we run the process in reverse. So we take the pressurized air, we take the heat, we heat up the air, and use that hot pressurized gas to drive the pistons of the same piston machine we used in the first place. That then turns a generator and produces electricity to serve the grid, to serve on-site needs for industry, electric vehicle charging, whatever they might be, or local microgrids. And this is about reusing stuff that already exists. So we take our air store, the pressure vessels, for example, from the compressed natural gas industry. They've been storing gas at 230 bar, 250 bar for many, many years. And we want to do the same, but we just want to store air instead of a fossil fuel. We store the heat in gravel or sand. Again, we're not going to run out of those anytime soon. And we use ex-service truck engines as our compressors. We work with Volvo. They have plenty of these 6-cylinder, 13-litre truck engines. It's the most common truck engine across Europe. Those are perfect for what we need. And as they make more electric trucks, they'll have even more engines to give us. It works nicely. But actually, the most powerful bit of that story is that it means we're working with existing supply chain players. We're working with existing maintenance players, because in every corner of the world, there is someone who knows how to maintain a truck engine, which is a fantastic head start when it comes to maintaining an energy storage system. So that is something that we're really excited about, that we can work with existing players. We're not talking about building massive gigafactories to roll out our solutions. We're talking about building partnerships with automotive players, with players that currently are building diesel generators. If we can do a few less of those and a few more energy storage systems, we'll be on a great path. So this is about offering partners a route into a clean tech sector that doesn't mean they have to specialize in electrochemistry. They can use their ability to put together mechanical systems, to put together and to do maintenance and change the oil on a truck engine. We're commissioning our first full-scale system in Nottingham right now. That's going really well. We had some great testing results just yesterday. We're working on a set of pilot units that will be deployed next year. And we're also working with one of the biggest mining companies in the world to demonstrate the solution in Australia. So we're focused on the commercial industrial space. Sadly, the home-scale cheesecake is still some way away, but commercial industrially, that's a really nice space for us to operate in. So we're looking at industrial energy users, looking at business parks and mixed-use developments. In that kind of business and logistics sector, we've got some great conversations going on with Amazon at the moment. They're really keen to decarbonize. We're also working with off-grid communities, industry islands. So again, some really exciting movement in that space. For the Colchester project, these are our pilot units. Colchester is massively grid constrained. So they're facing really long delays to get new grid supply in for a new mixed-use development. So instead, they're looking to build out a large solar park and run this big new mixed-use development as a microgrid, bringing lots more homes, as well as office space and amenities to the residents of Colchester. And if they were to wait for the grid, well, that's when the 2032 or 2033 conversation kicks in. So we've got a solution that is using thermal and compressed air to store electricity. It's durable, it's scalable, and it allows you to turn solar into 24/7 power. It's a system that is built within existing industrial parks, very sustainable, very green, and affordable. Right now, we're continuing to look for pilot opportunities, and we're also seeking investment. So either of those are of interest, do grab me afterwards. And equally, if you really want to know why we're called Cheesecake, I'll also be around. Thank you.
Thank you. I'm going to, great presentations. Thank you to all of you. Yeah, you can. Thank you. I'm now going to invite the next set, and we're going to deep dive into new materials. So if the pitching companies could come and join us, and then delighted to have Javier with us to be able to give us a few insights on new materials, first of all.
Thank you very much, Sylvie. So, pleasure to be here. I'm Javier Moya, I'm Professor of Materials Physics at the Department of Materials Science, and I'm also founder and CEO of Barocal, which I will tell you a little bit in a couple of minutes. I've been asked to set the scene for new materials, so I will do my best with the introduction. Materials are really key for us, are fundamental for humans, and they are so much that we actually refer to the main ages of civilization based on materials. From the use of flint to make the prehistoric tools, to the use of better and better alloys to produce better tooling. We went from the Stone Age to the Bronze Age and the Iron Age. Last century was also a big revolution. I mean, you may call last century the age of silicon. And that basically was underpinned by the discovery of solid-state semiconductors that basically been able to revolutionize the way we communicate and the way we work. And what I will argue is that this century, the 21st century, is the century for the basically energy materials or materials for the energy transition. And this is because as we are facing the big challenge of decarbonizing society, most of these technologies that are going to enable us to decarbonize society are based on new materials. And a particular area that I'm very interested is decarbonizing heating and cooling. Now, this is something that is very close to my heart. I grew up in Spain, where summers are pretty hot, so I was always very keen in cooling systems when I was growing up. And it's an area of research that traditionally has not been top of the agenda, despite the fact that when you combine heating and cooling, they represent 50% of the global emissions. That's a big chunk. And as today, we don't have a low carbon solution. So that's an important problem that we need to tackle as society. And I want to tell you is what we are doing in Cambridge to fix this problem. But before, let me tell you what we actually use nowadays for heating and cooling. For heating, we traditionally use gas boilers, so we use gas combustion, which is as old-fashioned technology as it gets. For cooling, we normally use vapor compression systems in air conditioning, so in fridges, where you exploit the fact that when you take a gas and you compress it, it becomes liquid, and when this happens, it becomes hot. And then when you decompress the liquid, it becomes gas again, so you are driving a phase transition between a gas phase and a liquid phase. And when that happens, the fluid gets very cold. So you can pump this fluid around in order to have your air conditioning system. You can also run it the other way around and then have a heating system, which are normally called heat pumps. And these are really the only solutions at the moment, replacing gas boilers by heat pumps. But despite that change, we're still facing big problems because heat pumps and air conditioning systems use gases that are highly contributing to the greenhouse effect. And moreover, the energy efficiency of these systems are quite low. If you look at the best systems that you have in the market for air conditioning systems or heat pumps, the coefficient of performance, which measures the energy efficiency, is normally between 2 and 4, so the average is 3. And that means that we are wasting a lot of energy that we could use otherwise. So what we do in Cambridge is to investigate a different type of technology where you get rid completely of the gas, and instead of exploiting a phase transition in these greenhouse gases, you exploit phase transitions in solid materials. And these materials are called caloric materials. There are different types depending on the type of material that you use and the type of driving field that you use to operate the machine. we are a specialist in barocaloric materials, which are the ones on the right. They are called barocalorics because we use pressure to drive phase transitions in solids. And then the idea is that you drive a phase transition between one type of solid state to another type of solid state, and then the material is able to increase the temperature and decrease the temperature when you do so, so you can replace the gases in cooling and heating systems. And I normally like to use images or videos when I can to explain how these materials work. So this is a video made with an infrared camera. So the color represents temperature of me with a balloon. So this is the cheapest caloric material that you can find. As you notice, when you stretch the balloon, the material gets hot, which in this scale is yellow color. And then when you wait to recover the starting temperature and then let it go, you see it's going to get cold, which is black in this scale. This is an example of driving a transition. In this case, the balloon is made of natural rubber. When you stretch it, it goes from amorphous to crystalline and back to amorphous. And then you can have a temperature change. Now, this is all very nice, and you can actually do it at home. You can use your lips to measure the temperature change, and this works. This is what I use with my family and my kids, so they understand what I do. But the problem with these materials, despite being around for more than 100 years, is that the temperature changes in solid materials traditionally were always very small compared to the ones that you have in gases. This balloon, for instance, can change temperature by 3 degrees, but vapor compression, gases change temperature by 50, 60 degrees. And that's what we need to replace. So this is just an example of the competition. This is a phase diagram for R134A, which is the standard refrigerant gas that you have in the air conditioning system in your car. And then if I sketch a cooling system in your air conditioning system, you will see that we need materials that are able to change, for instance, temperature by 30 degrees or more, and then a property that we call entropy in the region of 500 in the units of entropy. So we need materials that can compete with this. And we've been working very hard for the last 15 years here at the Department of Materials Science to find a replacement. And good news is that we found a replacement, because otherwise I would not be here telling you about it. We found some materials nearly 10 years ago that have phase transitions that involve the rotation of organic molecules. And the interesting thing is that the thermal changes that you can get in these materials are the same, if not more, than the thermal changes that you have in gases. So if you look at the graph on the top left, we can compare the thermal changes in terms of entropy. The orange dot is the gas that I showed you before that you have in your car, and the blue and the red data is an example of our materials. So based on this discovery, we filed patents with Cambridge Enterprise, and then we started commercializing the technology. We founded Barocal, which is the spin-out of the university developing this technology. The company's been operating 5 years. We started the company really in November 2019, just before the pandemic, so great time to start a company. And we have now second-generation prototypes that can actually compete with vapor compression systems. If anyone is interested to see this, we are actually doing a public demonstration this Monday at Churchill College, so if you're interested, let me know. And with that, I would also like to say that the university has also identified this area of energy materials as a strategic area, and we are launching a new master program next year, which is called Advanced Materials for the Energy Transition, so hopefully that will speed up the discovery of new materials that can underpin the energy transition. And with that, I'm very pleased to introduce the companies that are going to pitch, and I stop there.
Good afternoon. It's very difficult to overemphasize the importance of rice. I'm Craig Jameson from Straw Innovations. Rice is the world's #1 food crop. 90% of it is grown and consumed in Asia. And anyone from an Asian background here will know I've lived in the Philippines the last 12 years. People there eat rice 3 times a day. Can you imagine that? Rice for breakfast. But it has a dark secret. Its emissions are worse than the entire global aviation industry. They're as bad as all the other crops in the world put together. Nobody's really talking about this. What is the problem? Largely, it's the straw, the stalks, the stems and leaves that are being disposed of in the rice fields in very polluting ways. Simultaneously, there's a huge demand for this kind of biomass for clean energy, for biochar, for renewable materials. So if only we could get that straw out of the field and take it to these end markets, we'd be sorted, right? So why aren't people doing that? Well, the problem is largely rice is grown, unlike wheat, in floodwater or very boggy fields, and a lot of it is just unharvestable because the machinery doesn't exist today to collect it. And the British government was keen to understand why all this pollution when we could be turning that into a useful resource. So they commissioned one of the most comprehensive studies ever done on that. And I led that study, 3-year study, and we published in various journals and wrote a nice long report. But in a nutshell, what we discovered was there are 4 key barriers to using that. One is the logistics I just mentioned, getting the straw out of the field. Another is the physical properties of that rice. It's quite abrasive, it's got a lot of silica and ash in it. Another is that because of these barriers, there are business challenges. Nobody's really shown the whole thing working, and therefore it's considered too high risk for commercial investment. And finally, government policies are often not supporting or even hindering use of the straw. After leading that project, I started Straw Innovations, and by 2019 we had set up a 100-ton-a-year prototype in the Philippines, just south of Manila. And on the basis that if we could show the whole thing working, we could help to de-risk it and attract commercial investment and get this scaled out across Asia. Our solution is focused on the first barrier, which is the logistical problems, and how do you get that straw out of the field? And we developed a harvester that you can see the results on the left, cut much lower than the current ones. I won't go into the technology too much, but we've got engineers who've been working on this. It's an adaptation of current combine harvesters, which there are much smaller than here, and on tracks, caterpillar tracks. And just in May this year, I pitched successfully at the TechNation Rising Stars right here in Cambridge. It was one of the 3 finalists from that. Our business model is that we can work with combine harvesting contractors, usually small family businesses, and we can get our machines into their hands and collect that straw into a hub and then deliver it to different markets. The farmers that we've been speaking to about this for some time have shown that it's really something that they want. They want to get this straw out of the field so they can get started on their next crop. And so they're really benefiting. I mentioned the high emissions from rice production. This is a climate tech session. Clean tech, we are halving those emissions from rice, that red bar there, just by removing the straw before we've even used it for other clean end uses. And we're at the stage now where we are setting up a commercial demonstration, so we're going from 100 tons a year to 20,000 tons a year, and technology readiness level 7. And we have project partners. The International Rice Research Institute was with the first project. UK Aid has been funding this, so thank you. All you wonderful British taxpayers have been co-funding the commercial development through Innovate UK from 2017 to now, and we believe that we are bringing a revolution to rice production, transforming it from a pollutant into a surprising climate solution. I'd love to chat with you. If you're interested in anything in this area, I'll be around afterwards. Thank you. Really cool.
Alrighty. First of all, apologies. I'm a last-minute replacement for our CEO, so sorry you have to deal with a second stringer here today. So, Lambda Agri, we call it Better Light for Plants. What is the actual problem that we're looking at? Well, the problem that we're looking at is a global one. In our so-called civilized society that we live in, we have about 800 million people in what people euphemistically call food insecurity, which is another way of saying we've got 800 million people starving. Now, most people, or at least most decent people, would agree that this is both infuriating and shameful, and so there should be something done about this. The situation that we have is, to some extent, a distribution problem. Food exists, at least for the moment, but it doesn't necessarily exist where it's needed. This is true for even places like the UK. So, for instance, the vast majority of the vegetable and fruit that you buy at the supermarket will not be grown in the UK, will not have been grown in the UK. With that comes a huge carbon footprint. And on top of all of that, this is just the status quo. Climate change is real, despite of what other people might say. Because of that, we will have an increased need to do something about food security, and the way forward, people agree on that, is to grow food in protected environments, that is inside of greenhouses and under polytunnels. But that leads us to a local problem. If you are a grower, you will forever be fighting with the fact that you're dealing with low margins. Low margins means that between the capex of setting up your enterprise and the opex of operating all of that, you need to make sure that whatever you produce under that protected environment comes with the highest possible yield. People have quickly realized that, and so what they do is they add red LED lights. If you ever go, especially now that things are getting a little bit darker in the evenings, and drive along a greenhouse area, you will see that there's red glow lamps growing in there. But of course, these things also cost money to install, and more importantly, they cost money to actually run. I mean, there's an electricity cost, and if you have another situation like we had not too long ago, where a dictator decides that he wants to invade another country and energy prices go through the roof, then very quickly people will have to simply switch off those growth lamps, and you have a problem in terms of food production. So what is it that we do about this? What we are doing is we're developing materials that convert sunlight. That is, incoming sunlight, as you know, is composed of a variety of wavelengths. Some of them are more useful to plants than others. Some of them will have a larger photosynthetic turnover efficiency than others. Most efficiently, plants will be dealing with red light. So what we do is we absorb light at the short end of the spectrum, that is UV, a little bit of violet, and convert that into red light. And by doing so, you can get a huge economic benefit, and you can increase crop yields by about, give it or take, 20%. And in its first incarnation, this material is something we can apply in a spray paint. And you can either do that in a very fancy way with that robot you see on the right, or you can do it in the Screwfix 3995 variety, as we did it here in last year's growth trials at Cranfield University. And just by applying that, you have a passive, meaning no OpEx, associated with it, solution to boost your crop yields. Milestones, we've come quite a bit in terms of improving our generation of material. Things are getting better and better at converting photons. We had a few very small scale trials initially with friends and family. People essentially said, hey, you guys are making this, I'll give you a $5 if you coat a little bit of a structure in our garden. This summer we're going big. We're working on a couple of thousand of square meters A/B testing with growers in the UK, and we're trying very hard to get our way into the Netherlands, because the Dutch are the ones that control new technology when it comes to greenhouse technology, and so we're trying to engage with folks over there as well. Here's the other reason why we're doing this sort of thing. We like to pretend that it's all about making people not starve, but the other factor is the market for protected growth environments is gigantic. Even if you just look at retrofit greenhouses, and even if you take the subset of only what's available in the Netherlands, and if you take the only subset, if you only take the subset there of people in the Netherlands that are actually interested in trying out new stuff, you're still looking at stupendously large numbers, and therefore at a very large market potential. And then, of course, the idea of converting sunlight or any light source from one wavelength to the other has a host of other applications as well that we're going to look into at some point as well. Now, we're not the only ones and not the first ones to have this sort of idea. We have competitors out there. Their problem is right here where it says expense. If you have low profit margins and you want to charge something, call it 30 pounds per square meter, you're not going to have a value proposition to the grower that makes sense to them. So you've got to come with something that's a lot cheaper. The good news is that they already did a lot of the groundwork in terms of what's possible. For instance, the crop yield increase is now firmly established. You can get 20% give or take, depending on crop a little bit, by using this type of principle. Who are we? Monica is our rising star, shining star, forever star in the field. I've never seen anyone with this kind of work ethic. She is amazing. She just goes and goes and goes. There's no stopping her. We are located within the University of Cambridge, meaning we have advisors from the University of Cambridge, but we also have contacts with the University of Bath, then Cranfield University for plant sciences. Overall, we're pretty well stocked when it comes to expertise. We got our bases covered internally with business, with tech. We're in pretty good shape there. Like I said, Monica is amazing. Monica can go to just about any kind of award show or anything. She usually comes back with something, sometimes first, sometimes second. She had an off day at the Tech Nation Rising Stars, and she only came back third. It was a dark day for us. But overall, whenever you send her somewhere, or even if you don't send her, she actually managed to win something on Tuesday without ever going. She's amazing. With that, I'll leave you to it. If you do have questions, my contact info is there. At the same time, I also put up Monica's. If you have questions, if you want to get in touch with us, if you want to just talk, if you want to help, anything at all, please do. Always happy to have a word, and thank you very much.
Graveyard session. The properties of iron were well known for thousands of years. We've just heard that earlier today. But it actually took until the 19th century before we started using chemistry to modify its properties. And we came out with a revolutionary new material called steel, which is now propagated in so many sectors all over the world. Cell Excel's technology also uses chemistry. And this time, we're modifying the molecules in biomaterials to produce high-performance biomaterials, directly linking our agriculture environment sector to that of manufacturing. They should no longer be in conflict, but actually be mutually beneficial. Cell Excel's technology has been widely recognized, winning a number of awards, including this week being Best Startup at Cambridge Tech Week. And this is reflected in the traction we're already getting in industry, where we've already gained a number of contracts with 3 global manufacturers in the automotive industry and also several global manufacturers in the paper industry. But our technology, what I'm going to show you, is actually key to every single manufacturing company worldwide. By accelerating the adoption of and increasing the number of applications for carbon capturing biomaterials, embedded emissions in components can be reduced by a staggering 70 to 80%. We can do more and create less emissions. We don't need as much energy if we create less emissions. Manufacturers are crying out to use these materials to replace glass fiber and on occasion carbon fiber. But biomaterials' natural tendency is rather poor. They soak up moisture. They literally soak it up, expand, and crack some of these components here. So when you mold one of these components and it's machined or drilled, you expose the fibers, they absorb the water. Manufacturers have no choice but to then coat the finished part using PFAS, forever chemicals, or other non-biodegradable materials, which then gives end-of-life problems further on. We can lower embedded emissions in all of these primary materials, then we need less energy. To solve this problem, Cell Excel has gone molecular. We're working at 100,000 times smaller than the width of a human hair. No coatings, but using a sustainable chemistry to actually modify the cellulose molecules that are found in all plants worldwide. whatever the abundant crop, we can then modify and impact for that area. This unique solution opens the door for manufacturers to deliver net zero through exponential growth in the use of biomaterials. Here you see those little molecules at work. This is a hemp fabric which we've treated. Untreated just absorbs water, and you can see the water being repelled here. In these samples, we've cut the fabric. If this was a coating, you would immediately create a leak path. And you can see on the right-hand treated sample, there is no, the water is fully repelled. Now the performance of these materials matches the needs and wants of nearly every manufacturing sector. We focus the business on two applications within one sector. That's the biocomposites and seating materials within the automotive industry. If you look at it another way, one is where we're treating a material and that's then embedded in a higher supply chain, or one we're treating a material which is the end application. This sector has relished our technology, and since exhibiting it in March, we've already gained supplier codes from 2 global automotive companies and are actually engaged in a third project with a UK company. And we're also working with a niche automotive technology company that's looking to put these new technologies into demonstrator vehicles and ship them around the world. CellXL's impact goes far beyond automotive, though, with demand from the paper, electronics, and fashion. This material here are pineapple fibers, and you can see our treatment here is just working with the cellulose. And this is paper. Become viable. Could our technology double or triple that market? The cost of applying our technology is small. The gains could be huge. Excitingly, we're also exploring how our platform can impact other properties. So not only impacting water resistance, can we make those properties to impact fire resistance, antifungal, or even possibly increase its tensile strength. CellXL itself, as a treatment, is applied using all existing capital equipment within the value chain. While custom projects and working with these large companies is key to us in generating income today, our primary revenue will be through a license model, providing strong repeating revenues, minimal capital investment, and a plateauing cost base. While our secondary revenue stream will be at selling the actual product, CellXLent, our treatment manufactured using a toll manufacturer. It's been an absolute pleasure for me to assemble this team, who have delivered an EU patent and applied for a second. We're based up in the Norwich Research Park, where we have access to some great facilities. Yes, I was bold enough to say that in Cambridge. And work with partners around the UK, including the Biorenewables Research and Development Centre. Our diverse board has already recognised that it's important to put in place incentivisations and a caps table for all stakeholders. As critical a step maybe for all of these startups as the technology itself. We've already gained some well-known backers, including the University of Cambridge, must be recognising Norwich again, and a number of capital and low carbon innovation fund. We also have some advisors like Dr. Faye Smith, who was the UK government advisor on composites and is a member of UK Composites Board. The level of interest in our tech has been exceptional. Thank you for supporting, listening to our story, and also helping the journey of every other manufacturer worldwide.
Thank you very much. Thank you to all the companies and the experts for these 2 sessions. You can join your seats now. Thank you. So I set you a challenge earlier in the afternoon. Maybe you remember. It was to find at least to note these 5 new things in your notepad on your phone. I mean, I'm sure by now you should have more. If, like me, you're not an engineer or a researcher, you probably learn quite a lot from these guys here. To conclude the session, and also to conclude this week, I'm delighted now to welcome Professor Emily Schuckberg from Cambridge Zero. And I want to hear, is she going to shake us and say, you have to do more? Or are we going to finish on an optimist side? I don't know. Let's discover. Emily? Excellent.
Thank you.
Can I just check? Can you hear? The microphone is okay?
Yeah, good.
Okay.
Thank you. Well, you set me the challenge at the start of this afternoon. I was supposed to leave you all inspired. I actually think that what's happened over the course of this afternoon is almost the opposite has happened. Do I need to use this? There we go. Okay, I will do. Right. Almost the opposite has happened. I feel that you have all inspired me with everything that we've heard over the course of this afternoon. So what I want to do is explain to you why I say that. I'm not an innovator, not really. I'm a climate scientist. I lead Cambridge Zero, which is the University of Cambridge's climate initiative, which spans all the activities of the university, but particularly the research and innovation that's conducted in the university. So I do have an oversight of some of the exciting things that are happening within the university. But what's been really exciting for me today is to be hearing about all the real-world innovation that's been happening beyond the university. But what I wanted to do is to start off from my world, the climate science world, because in many ways that is the challenge that we are all looking to respond towards. And my story is, to be honest, not nearly as inspiring as the stories that we've been hearing this afternoon. This is really my story. This is where we are today in the world on the climate journey. And whereas we've been seeing some graphs this afternoon that are much more optimistic in terms of growth of investment in clean tech and climate tech, this is a story where all the exponential curves mean bad things rather than good things. So you can see this is all data from 1850 to the present day in terms of world energy use, most of which is still fossil energy today. There's a tiny little bit of renewable energy in green at the top there, driving those carbon dioxide levels in the atmosphere, which are still growing really significantly, and then temperature and sea level. And again, in my world, the aspects of this that are probably most concerning are the risk of passing tipping points in the climate system. I spent a long time studying the polar regions, and one of the greatest concerns is those polar regions passing tipping points in terms of the vast ice sheets that cover both Greenland and Antarctica, or methane release from the frozen land and in the oceans in the Arctic. So tipping points that could have a disastrous effect on the whole planet. But what's exciting is, and we've heard some elements of it this afternoon, is the possibility of passing tipping points in terms of our responses, tipping points in terms of new materials or energy storage, or some of the exciting examples that we heard in the last session in terms of making agricultural productivity much more efficient. That's where a story that is my story on the science side of things, of effectively doom and gloom, turns into a story of excitement and hope. And that's why I felt so energized by this afternoon. The science can go further, and it can show you This is where our emissions have been over the last few decades. This is where our emissions need to go over the next few decades. So they can show you the scale of the challenge that is required. And we can dig in more detail into that and see where we've been going just as the UK, sector by sector, in terms of our emissions reductions over the last few decades and just how far we still need to go. This data showing there's been quite a significant reduction in emissions in the UK overall, about 50% reduction over the last few decades, but most of that has come from decarbonisation of electricity supply, rather little change in other sectors, and that's where in my world I often think that this is the big challenge, but in your world is the huge opportunity. And if we're looking into the future, surely it is that where we see the great hope. Now, I did do my homework and come up with my own list of 5 key things that I had gathered this afternoon from the presentations. The first thing from my world, though, is that any of the innovations that we're looking at, if they have a substantial difference on this challenge, then the numbers have to add up. And so within all of that, what were the key lessons that I took away from some of the presentations that we heard this afternoon? The first thing is that if we are to come up with effective innovations and effective solutions to exactly this challenge, then those solutions need to make economic sense. The quote that somebody gave from Bill Gates, that we are in a post-subsidy world, that this can't be just about doing good for the planet. In your world, that might be true in my world when I'm looking at it from a climate science perspective, but in your world, it needs to make economic sense. That the market matters. Somebody said, be clear what the problem you're trying to solve is, be agile, move with the market. Somebody else highlighted the problem of spending a lot of time in creating perfect solutions, but the ones that nobody actually wants the solutions to those problems, or they don't quite fit what the market needs. Clearly, you know, many people here have been involved in different aspects in terms of the investment. Lots of commentary around the importance in this sector of capital investment, but also, of course, of de-risking those investors, and some discussion that we had as well around the role of governments in setting policies and regulations. One of the comments that was made around that really resonated with me, again from the climate science perspective, was the role of regulations in helping to ensure that unintended consequences didn't occur. Coming from the climate science perspective, those unintended consequences are something that I'm always very aware of as a crucial element of need for consideration. But then perhaps the fifth, sorry, I did have 4. I didn't really articulate those 4, but within what I just said, there were 4 different points that I'd come up with. The fifth one, though, that I feel is probably the most exciting and important that's come out over this afternoon is really one of climate leadership. Somebody even had climate leadership as a bullet point on their slide. And I found it hugely inspiring to hear about the concepts of developing not just an ecosystem, but a clean tech innovation supercluster. And within that, aspects that I have always felt to be incredibly important about bringing together all of the case studies we've just been listening to. It also means that you can build up the networks and the collaborations that will help accelerate the innovations to respond on the timescales required. So one of the aspects that makes the climate challenge particularly exciting and interesting is, compared to other innovations, there is a particular challenge that we're trying to solve. There is an end goal we're wanting to in the climate world, but also there's a ticking clock. So it's not just there's a particular solution, there's a particular solution that's required over a particular period of time. And so that ability to not just innovate creatively, but also to innovate creatively in an accelerated way is a critical component of delivering this response. And so looking at ways that you can ensure that you're creating some kind of feedback loop that enables those tipping points to enable that acceleration is really, really important and can only really be delivered by radical partnerships. Partnerships, some of which we've heard about, again, over the course of this afternoon, might be between small innovators and large corporates, or creating a closer collaboration between the policy environment that enables those new innovations to rapidly acquire market growth and to de-risk the investments associated with them. Those sort of radical partnerships are absolutely critical. The other element of the radical partnership, which perhaps didn't get mentioned so much today, but which I think is also really important, is to have the global scale change that's required to deliver against this problem means that any of the innovations and solutions that are being thought about in this room and beyond really do need to, over that accelerated timescale, also have really broad broad uptake around the world. And in many instances, maybe this comes back a little bit to the market question, in many instances that is going to involve not just technological innovation, but also what's sometimes called behavioral change, going hand in hand, and that any of the solutions need to be very, very inclusive. Whenever we do work looking at more general audiences and their views of what climate solutions could look like, the importance of fairness and inclusivity being at the heart of any of those solutions always comes out. And so ensuring that that fairness and inclusivity is embedded in the design process of any innovations also feels critically important. So, bringing all of that together, this is the world that I normally live in, and I really do think that people in this room, whether you are innovators or investors, are the hope, the solutions, and the opportunity to what is normally my narrative of the challenges, the risks, and the threats. So I wish all of you the most luck into the future, whatever different sectors you might be working in, whatever different innovations you might be working in, whether it's transport, energy, digital and AI, agriculture, waste, buildings, industry, removal of carbon dioxide or methane. We've heard about many of these different sectors today. This is a hugely exciting opportunity. It's hugely exciting to hear how Cambridge is driving forward this agenda. Hugely exciting to have Cambridge Tech Week and for this to have been an important part of the agenda. And I'll just leave you with one final comment, which does come from the climate science, from the Intergovernmental Panel on Climate Change's report of just over a year ago. It said that there's a rapidly closing window of opportunity to secure a livable and sustainable future for all. I put that next to an image of King's College from the summer, where you can see a wildflower meadow that they planted in recent years on the back lawn, and what you can't see in the photo but is there are the solar panels that are now installed on the roof of the chapel. Change is possible. We can really create a better future for all, but you are all absolutely an instrumental part of it. Thank you.
Thank you very much, Emily. What an afternoon. We've got lots of work to do, but we are inspired and we can do it together. So join me one last time to thank all the speakers for this afternoon, the partners for the Cambridge Tech Week, but also the team at the Cambridge Tech Week, powered by Cambridge Wireless. They did an amazing work, and it's been a tough week for them, months of preparation, so let's thank them. And thanks to all of you. I think now we can just probably go and have a drink and network. Yeah, you've got the instruction here at the graduate. See you there.